black energy. On the ultraviolet end, it does not radiate heat like it does on the infrared end. So therefore, when you put on a black shirt, it does not have to come off the high end of blackness. It can come off the lower end. So no, you're not going to get radiation from that level because the entire electromagnetic spectrum is a spectrum of black energy. It's not just on the high end, it's also on the low end. So when you put on your t-shirt a radio wave, it comes from the lower end. It still is black energy. That's what y'all understand. Yeah, and because I may not articulate it all the way because I don't have time, I do get excited sometimes when I'm talking. But once again, it's not just a high end of black energy, that also is what we call a lower end, but it's still energy in the black spectrum. So ultraviolet light, infrared light, all of that is black energy. And when you ignite black energy, it gives you a white explosion. So the white light is the black energy in an explosive form. And when you send it through a prism, you get the colors red, orange, yellow, green, blue, and black. And that's the reason they do not make white the primary color, because if they make white your primary color, you come to the fact of knowing that white light is a byproduct of a black body.
No, purple or purple light, dark purple light doesn't come through the electromagnetic spectrum. So I kind of understand what he's saying. He's not articulating it clear, but I think I understand what he's saying.
Bruh, you heard him just say the black body, right?
They're not body. I mean, that's what I'm saying. Definitions and word definitions are important when you explain things, even if it's real basic. His body, because the light's not a body, so to speak, anyway, on the electromagnetic spectrum. It's not a body. It's a thing. It's invisible ultraviolet light. Yeah. It's not a body.
My point is the science never wanted black to be in the category of light. If it is in the category of light, it then gets in the category of God. So what I'm trying to do is point out that black is radiant.
Black and purple light is a part of the like science literature and definitions. I don't see anything wrong with that.
But no. I'm not talking. I understand. When they give us purple light, they tell us the purple light is black. Now I'm talking about. I'm talking about black, like midnight black.
The ultraviolet light is not fucking black, bro. They assign those colors to ultraviolet, bro. They literally assign those colors to like when you see a black light, when they call it black light, that is not black light. What that is a tube filled with gas, and the electric current that passes through the gas makes the gas irradiate. It makes it irradiate. The color of the light is dependent upon what substance they put inside of the tube.
I'm talking about
it's dependent on what substance they put.
You're not understanding what I'm talking about. Brother, you're not understanding what I'm talking about. They've never shown us true black light.
But you can't see it,
light inside of
it's invisible.
It's invisible.
But like purple, you can see,
but you can capture it on the right background. If
Brother,
you have X-ray paper,
don't capture anything. It reflects.
Okay. When I sent the picture of the spectroscope capturing light, if you look at that picture that I sent, it shows you the rainbow color, and at the top of that rainbow color, you see black, not a purple color, because they know in the rainbow when you look at it, the atmosphere itself cannot show you the black light. So that's when you have to have the right background to then capture it.
Nobody has ever seen a rainbow in the sky.
Back and look at the picture. Okay, in the text that I sent today,
brother,
no
one on earth has seen a rainbow with black bands in it. No one.
Okay, listen. That's when I showed you the bubble, because you have to have the right medium to capture it.
The bubble.
X-ray paper. When I showed you the X-ray paper, If you look at X-ray paper, how X-ray paper looks before it is put in the X-ray machine, it's a clear-looking paper. Then when they capture the image, you see the black image on the paper. It is then captured the black. So when you start saying that your shirt is not radiating X-rays, no, because they don't get it at that high level energy. They go down the spectrum. They may get it from the radio wave, they may get it from the microwave, they may get it from whatever, right? But the entire electromagnetic spectrum is black. So that's when I tied the Bible into it, which in turn offended a lot of people. When I said, when God said, let there be light, this blackness throughout the universe is the electromagnetic spectrum. And we have different names by classifying. We say this end is gamma, this end is X-ray, this end is ultraviolet, this end is visible, this end is infrared, this end is microwave, this end is radio wave. It's still black energy. And when you ignite it, it gives a white explosion. So the white light is the byproduct of black energy exploding. Green light explodes a green light. Blue light explodes a blue light, but a black object explodes a white light. And when you then send the white light through a prism, it breaks down to 7 colors: red, orange, yellow, green, blue, purple, and black, which is what you cannot see. And when you mix them together, then you begin to see what the white light actually is. The white light is the black substance in an ignited form.
But we can see black, brother.
I'm not saying you can't see black. That's letting you know. If you can see black, that's letting you know that you're looking at light.
So
But they made you believe that you're looking at darkness. Okay, let me
when
show
the
you.
light is shining through a prism, we don't see black, brother? We don't see that.
That's when I showed you the spectroscope. The prism is a half of a triangle. It's not going to capture all light. Look at light through a spectroscope. Then you see the red, orange, yellow, green, blue, purple. Then you see the black. Look at in the text that
you
I
only
sent.
see the black. You only see the black in those images because there's nothing there to emit or absorb photons, brother. That's why you see black there. You see those other colors because there's something there to absorb or emit photons. And this is what you're not understanding. And like he keep explaining to you, it's the same thing with the X-ray. It's not that the X-ray is the image is capturing X-rays, you know what I'm saying? And that's why you see the black in the X-ray image. You see the black because there's a void there. There's something there that's not capturing or reflecting light.
No. When you look at an X-ray image, X-rays cannot go through bone. X-ray cannot go through bone. X-ray goes through the flesh.
So it reflects off of the bones and tissues, and this is why they show up as white and gray. But it doesn't reflect off of the air. It passes through the air, so the air shows up black in those images. I just dropped a link in the back chat that explains that. If you want to go look at it.
When you look at X-ray paper, how it looks prior to you putting in an X-ray machine, it's a clear-looking paper. Then they put it against an image. X-rays do not pass through bone. So as it passes through the flesh, the background material, which is the paper, captures then the X-ray color, which is black.
That's incorrect, brother. That's incorrect. What you see, the black that you see in
let me ask you, do X-rays pass through bone? Can an X-ray pass through bone material?
No, they don't. That's why
so what do they pass through?
That's why the bones show up as white, brother, exactly. and the tissue shows up as gray because the bones and tissue are reflecting the X-ray. The bones and tissue are reflecting the photons as they pass through, but the air, brother, doesn't. So the air, like inside of your lungs, which would be on the X-ray, show up black, brother.
They've taken. Okay, look at an X-ray. Look at an X-ray picture of a hand. You'll see the white bone, and then you'll see the background. Because once again, it takes the background to capture the X-ray. That background, prior to them putting in that, you got a clear sheet of X-ray paper. And when you put your hand up there, the hand is going to be white but the background is going to be black. It starts off clear, but when the X-rays are captured on the film paper, then you see a black background. The bones in the hand.
That's because the air around your hand is showing up black, brother. It's the same thing like the air in your lungs.
But no, we're talking. Okay, okay. Listen what I'm saying. If I put my hand on a machine and they shoot a X-ray image of it, the bone material will not go through the X-ray. So the background, which is the film paper, then captures the color as to what X-rays are. The film material captures it. So it captures this black image back there to show you what X-rays actually are. But once again, I didn't have time to explain all that because when you're hearing new information for the first time, it takes time to explain it. So when they say time, I said, damn, I didn't even get a chance to get into this. So that's when I say, but it helped me because as I get my PowerPoint presentation, a picture is worth 8,000 words. But once again, go look at a spectroscope because a prism does not capture all of the colors of light. A spectroscope does. But when they explain a spectroscope, they don't know that they're looking at black light. So they would think that it's in an interference pattern. And so when I sent the picture today, go back and look at the chat that we had. I sent a picture, and that white slit in the middle is where you put a white slit and sent white light through the spectroscope. And at the spectroscope, you'll see black starting out first, then it goes to purple, then it goes to red, orange, it goes to blue, then it goes to green, then it goes to red, yellow. At the top of that rainbow, you will see black light. That's not an interference pattern.
Brother, it's what it's saying is those are absorption spectrum. It says
that's what they're gonna say. They don't know. That's what I'm saying. Because they don't want to acknowledge black light.
Brother, calm down. I just started speaking.
Okay.
It says an absorption spectrum is a spectrum of light transmitted through a substance. There you go. Through a substance showing dark lines or bands where light has been absorbed by atoms, causing a dip in the spectrum. The emission of the spectrum is made by electrons falling down the energy ladder. So what it's literally telling you is there is nothing there. There's nothing there. That's what they're telling you. There's nothing there.
What I've been trying to say. They've been trying to say black is nothing the whole time. That's my position. Black is something. Because that's when we look at ourselves like that, because they want you and I to say that there's nothing there. There is something there. It's black radiant energy. That's God I've been beating.
Black is something when you're dealing with materials, when you're dealing with atoms, when you're dealing with molecules, when you're dealing with compound substances. That's what they're talking about. This is the reason why we keep telling you that you're mistaking atoms and molecules for photons. That's the reason why we keep saying that. And you keep proving us right, because everything you show, like when you showed that video of him mixing those colors, those were chemicals he were mixing. Those were chemicals.
Hey, David, go back.
I'm not done. He mixed chemicals and he shined light through those chemicals. You know what I'm saying? So what you saw was not blackness. What you saw was the mixture of those chemicals together, creating that shade. That's what you saw. You did not see that. You did not see the light itself projecting darkness or black, because it can't. It does not do that.
Okay, let me ask you something about what you just said. He took three fractions, right? He took three
substances. He took three substances.
No, let me finish. He took three fractions and made a whole. Bruh. So why is the whole the primary?
Brother, again, he put chemicals together. Those
three
were chemicals,
right?
Brother, he put chemicals. Brother, he put chemicals together, not photons.
Okay, let's deal with the chemical. Let's deal with the chemical then. Let's deal with the chemical side. He took three fractions, right? So we have to take this step by step, because if we don't take it step by step, then we'll get way down the road without understanding the first step. He took three fractions, correct? Is that correct?
I mean, if that's how you want to interpret that.
And he took three fractions and made a whole. Is that correct?
if that's how you want to interpret the
And see,
information.
this is how you realize that there is resistance to truth. When you start saying that's how I want to interpret it, those were the facts.
Brother,
He took
that's
three
because
fractions
and the
and made.
reason
He
why
took 1/3. Let me show you the mathematics. Anytime your denominator is the same, you add the numerators. He took 3 and made a whole. So
brother,
now, as he took the 3,
first of all, the blue was a whole, the red was a whole, the green was a whole. They were whole. It is completely blue. It is completely green. It is completely red. Those are not fractions. Those aren't fractions.
okay, they're not fractions. Okay,
Hold on,
okay.
I'm not done. Those will be considered whole numbers if you want to translate them to numbers. Those will be whole numbers. So he put 3 whole numbers together. Is what he did. A fraction of those colors would be red and white, which makes pink. That's a fraction of red, a fraction of white. If he did let's say for instance green, that's a fraction of blue and a fraction of yellow. But that's not what he did. He put blue, which is the entire color of blue, the entire color of red, and the entire color of green. So tell me, how did you get fractions out of that?
I'm gonna tell you how I got fractions, because when he mixed them together, and if you reverse engineer the process, you can take blue out of that black, you can take red out of that black, and you can take green. That's when you fractionalize it. When you take a stick, for example, if you take 3 pieces of a stick and cut it up into this little piece, and this little piece, and you stick it together, you got one entire stick. Now, if you cut that stick up into pieces, then you fractionalize it. That's mathematics.
Brother, did he cut the blue up? Did he cut the red up? Did he cut the green up?
He started off with a. Okay, this is what he did. He started
because you're calling that fractions. You're calling that fractions when those were wholes. Those were not fractions.
Okay, let me ask you this. Let me ask you this.
Don't ask me nothing. First, you need to grasp the concept that was true blue, that was true red, and that's true green, and those were wholes. You have to admit that first. When he mixed,
let me ask you about what you're saying.
I'm not done. When he mixed the 3 together, that's 1 + 1 + 1. That's 3. That became the 3 became 1 because he mixed them all together. So again, you're calling them fractions when they're not fractions. Fractions mean it's a piece of this and a piece of that. That's what it means. That means it's some of this and some of that. That's what a fraction is. If I say 1/2, that means there's a half over here and there's a half over here. If I say 2/3, that means that it's 2 right here and there's 3 over here. That's what that means. But that's not what we saw. We saw 3 wholes being mixed together to make 1. That's what we saw.
Okay, now let me ask you something about what you just said. White light is composed of what we said 6 different colors.
I never made
white light is composed. Wait. Let me finish. Let me finish my sentence. Let me finish. Let me. Okay. Yeah. Let me. Okay. When you look at white light and you fractionalize white light, out of white light you can get the color orange, yellow, green, blue, purple. So therefore, you take pieces of the white light and you fractionalize them. So when you look at color blue, when you look at the color green, you look at the color red, it is a fraction out of the white light. That's when they're called fractions, because they come out of a whole. So what he did then in that video is he took 3 fractions of light. He took blue, he took green, and he took red. And when he mixed them together, then you had the color black. But if you go back and look at that entire video, He then takes the same color and he shines it on a screen. And he says in the video that you're not looking at a white screen. So when you shine red, green, and blue light on a screen and put your hand in that white appearing screen, the colors going to show up as cyan, magenta, and yellow. Cyan, magenta, and yellow. And when you mix cyan light, magenta light, and yellow light, you're going to come up with a black light substance. That's what I was attempting to do last night by me trying to hold a computer and do it. I couldn't do a good job. And so when I put a device, which it was a mirror, which is I put a device where light can shine through it. And when I put this, when the cyan, magenta, and yellow light came together, behind that, you saw a black object.
Brother, what we saw was the shadows of those objects. That's what we saw, shadows. We saw shadows of those objects. Again, this is the reason why I said when there was no object in front of the screen, the red, the blue, and the green light were still shining on that screen. According to your logic, because you put all three of those lights together, the screen should have appeared black. If what you were saying is true, the screen should appear black, not white. It should appear black because you're saying the combination of those colors create black. Okay, then how come the screen wasn't black? We only saw black when you obscured the path of the light, and the light cannot penetrate through the object, so it casts as a shadow. I showed you that. I put that shit in the back chat for you. I even put down the breakdown where it's telling you that those are shadows. And you're overlooking, you're ignoring, you're negating the fact that those are shadows and not light. Because again, if the red, blue, and green light together makes black, then why wasn't the screen black?
I never said red, green, and blue makes light. Okay, let me talk to the audience, because right now you and I are going to continue with the impasse. When you take red light, any of y'all can do to take red light, green light, and blue light and shine it on the screen. It's going to give you a white appearance. A white appearance to let you know that it's not true white. Is when you put an object inside of it, then three shadows showed up. Because if you have a true white screen, a black shadow will show up. But when you put an image, when I put an image in the red light, the green light, and the blue light, three other shadows showed up. A cyan shadow, a magenta shadow, and a yellow shadow, showing you that the light was not giving a true white light color. But now let me finish. Let me finish. But what white supremacists did, because it looked white from a distance, they then came along and said red, green, and blue are the primary colors of light, because they were hoping that you never experimented with it. Let me say it again. They say the primary color of light is red, green, and blue. But when you shine it on a screen, it looks white until you put an image in it. And once you put an image in it, then all of a sudden you begin to see, wait a minute, this is not true white light. And so what shows up then in that on a background is cyan, magenta, and yellow, because what you have a shadow looking white. And once again, and when you put it, and when you put an image in that light, then the color that will show up is cyan, magenta, and yellow. And in the pigment aspect.
Again, brother.
I'm talking to the audience. 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 I want y'all to do it so we can. Yeah. So.
Well, I mean, he's been doing that this whole time. Gets galloping. Ain't nobody stopped him.
Yeah, you keep trying to interrupt because you don't want information to get out.
I'm saying you keep repeating the same thing over and over and over again, and we're not getting
evidently you're not getting it. Okay. And what you're gonna find out is those three colors, cyan, magenta, and yellow, will make black. And the same way cyan, magenta, and black will make that in what's called pigment. The pigment is black the same way the light is. And once you make that connection between the black light, you begin to understand that the black light and the black pigment are one and the same. And that's what they want us to believe, that the pigment and and photons are different. That's when I was showing once again that 3 colors of light, cyan light, magenta light, and yellow light, produce this black color.
So
Um,
y'all just heard him say that pigment and light is the same thing. When pigments are made of fucking atoms, protons, neutrons, motherfucking molecules and shit, and light is made of photons. They're not the same. And to keep on sitting here feeding that shit to the people, nigga, is disingenuous. Again, I'm gonna show you. In science, when you're doing experiments, you have what they call test subjects. You have control groups. In order for you to prove what you're saying, you would have to put a black background up there, shine the same lights, and the light shine, the shadow is white instead of black. You see, now if you can do that, fine. We will have to consider what you're saying. But when you showed your experiment, you show a white screen or a gray screen. I don't know what color the screen actually is. When those three colored lights struck that screen, the screen was white. We did not see anything that remotely looked black until you obscured the light with a solid object. And only then did we see the shadows. And the shadows are not light. The shadows are a negative of an object in front of the light. That's what it is. So
okay,
again, you're gonna have to explain when the camera faced the fucking lights. When you turned the camera around and we saw the 3 lights shining, those 3 lights are less than 6 inches apart from each other. We can even see where the light interference pattern of each color blend together. And guess what? There was no black to be seen. When we looked at those 3 lights from the camera, we did not see blackness. We all saw white. You can keep saying that this is really black when we're actually seeing white.
I don't. Okay, let me.
Do you
I'll let you
you
talk, and I'm gonna talk
understand?
to the audience. I'm gonna let you talk. I'm gonna talk to the audience.
Do you understand that you're telling us if you put these 3 lights together, you're gonna get black? But when those 3 lights were together on that screen, we didn't see black until you obscured the path of the light. That's when we saw black, and it's only because there was a solid object in front of the light. Anybody who has ever done puppet shows, you know, shadow puppets and shit, they understand this. You saw shadows because the light was shining behind the fucking behind the object itself, casting a shadow, not casting light, it's casting a shadow. The shadow itself is not emanating and illuminating light. It's not. It's a shadow. So again, you're gonna have to put together control groups. You're gonna have to do an experiment with control groups, meaning not only do you got a white screen, you got a black screen, a green screen, a red screen. You got all these different screens, and you're using the same light, and you should be able to get a white shadow. You should be able to get, you know what I'm saying? Because you're literally saying that this white light is really black. Okay, so when you put it up next to a black background, you ought to see a white shadow, right? Because the black is really white, right? See, and when you use that logic, you're gonna see that your whole logic breaks down, bro, when it comes to actual reality that we're seeing. We saw last night, you have three different color lights right next to each other. And when it shined on that screen, all we saw was white light until you blocked the light with an object. And then we saw the shadows of the object, and you called those shadows light. That's what I'm saying. That's what I'm saying, Karema. That's what I'm saying, Karema. It, if what he was saying was true, then
Okay, let me explain. Let me explain. Let me
I'm
explain my
talking.
experiment. Let me explain.
I'm talking. Hold on.
You trying to explain my experiment? Let
Hold
me
on,
explain
brother.
my experiment.
I'm talking though. So with Karima, with his logic, he's saying that these three lights create black light. So therefore, we should have seen black light on the screen with or without an object in front of it.
Let me explain.
No, he didn't. No, what he was saying was these three lights create black light, Karima. That's what he was saying the whole
I
time.
gotta write it down because I'm trying to get on the.
No, it didn't. No, it didn't. No, it didn't. All we saw was shadows being cast. We saw shadows. Yeah. Okay. So just you can call it whatever you want, but I'm. Well, what up?
19 what?
Like the shit crazy because and then, nah, no, you can't because everybody saw the shadows. Everybody saw the shadows, man. Yeah, that's because what he's saying is not what I'm observing. All I'm saying is Karima. This is all I'm saying is what he's saying is not matching up with what I'm observing. That's all I'm saying.
Okay. All right. That's all right.
Well, again, I can deal with what we agree with. Yeah, but that's not where he's going with it. See, we all agree. Karema, we all agree that we saw. We all agree. We all agree that we saw. We all agree that we saw these three lights. We all agree. We all. Well, it's not a back and forth argument if you just acknowledge what you saw. Right. Well, I'm just saying, this whole time he been saying that we're biased. We're biased because of how we've been taught, but he's not biased by what he's teaching. Like that's crazy. So I'm saying like if it's bias on one end, it's gonna be bias on the other end. If it's biased because we was taught this way, it's biased because you're teaching it this way, and it's not the reality that we seeing. That makes it biased too. Oh man.
Okay. Let me. Okay. Now, going back to what I was showing about the red, green, and blue light.
Let's see if you get stopped for going back.
According to science, that the red, green, and blue light make a white light. And so when I showed the white light, that is what they use as white supremacists to say that this is the color. These are the colors of these are the primary colors. So then when you put a shadow or any object in the red, green, and blue light, you should not be getting a colored shadow. You should be getting a black shadow in true white light. So then those three colors that you see are cyan, magenta, and yellow. You got to ask yourself, well, how is red, green, and blue light making cyan, magenta, and yellow? Because red, green, and blue are what's called the secondary colors off of cyan, magenta, and yellow. The primary color, then when then those three shadows that you saw on the screen, cyan, magenta, and yellow, and when you blend those three together, then you get the color black. And when you start taking the shadow up, the cyan color shows back up, the magenta shadow shows back up, and the yellow shadow shows back up to show you that black is the primary color of those three. That was the point I was making. And then that is what's called the photon aspect of the equation. Because we're dealing with light right there, but you need the right background to capture it. If you don't have the right background, you're not going to capture it. So that's when you put a screen up there. You put a screen up there, then you capture the same way with the X-ray. If you don't have the right screen, you will not be able to capture what X-rays look like. So they put X-ray film back there to capture this black energy. So once again, when I took the red light, the green light, and the blue light, I captured it on a background and it looked white. But to show you that it was not white, it did not produce a black shadow. It produced 3 different color shadows. Once again, cyan shadow, magenta shadow, and a yellow shadow. And then when you mix those 3 together, then you got the color black. And that was not an interference pattern to show you that black is the primary color that produces all of that. That's how you reverse engineer it. Reverse engineer, you take the one and start reversing it, and then you start saying, okay, the black can produce the cyan, magenta, and yellow, and then the cyan, magenta, and yellow can produce the red, green, and blue. That's the point. But once again, once I put it in a PowerPoint presentation, I won't have to spend so much energy trying to talk about this the way that I am, because people that see it, that understand it, that have a high understanding, they're not going to be bucking against it. They're not going to say, oh, you're wrong, you're disingenuous. They will see the information, and then they will process it. Then they'll start trying to find, well, let me process what I just saw. But right now, immediately you want to argue with it without even trying to process it. Let me think about it. When somebody asks me a question I don't know, I say, wait a minute, I hadn't been asked that before. And I try to look at it with a panoramic view. Is this right about it? Is this wrong about it? Is this right about it? Is this wrong? I don't just answer questions. I don't just jump on it and start saying you're right or wrong. I have to think about something. When somebody asks me something I've never thought about before, I stop and say, I don't know. I don't know. Because I need to look at it from every angle. That's why I look at something. But you immediately, you should be seeing a black screen. I never said you're going to see a black screen.
Brother,
I didn't say that.
Brother, that's because you said those 3 lights together make black light.
They said that. I didn't say that. I say cyan, magenta, and yellow make black light.
Brother, are those 3 colors? Are those 3 colors?
What 3 colors?
What you just said, are those 3 colors?
Yes.
Cyan, magenta, and yellow, right? Those are 3 colors, right?
Those are 3 colors, yes.
And when you put them together, they make black, right?
That's correct.
Okay, so why we didn't see the screen look black?
It wasn't a screen. Okay.
Again, this is what I'm saying. When what you're saying does not match up with what
okay. This is what you're saying.
I'm talking. Again, when you say that these 3 colors make black light, and then when we saw those 3 colors shine on the screen was not black.
Let me tell you why.
Brother, you don't have to explain anything. We all saw it. I just put a picture up. I just put a picture up in the back chat.
Okay.
Right?
Let me explain. Let me explain, because I see what you're doing.
I'm still talking.
Okay.
And again, I just put the picture up in the back chat. This is your experiment. Those are your lights. When the camera is facing the lights, you can clearly see the separation of the colors, and you can see where the colors blend at. When you see the magenta or the red next to the blue, when you see that, you see right in the middle between them, you see a purplish color. And when you see the red and the green next to each other, you can see the yellow color right there within the gradients of those colors. You're not seeing black at all. If you're saying that these color lights together make black, when with those lights in that close proximity of each other, the result should have been a black light cast on anything that the light struck. But that's not what we saw when we looked at the screen. When we looked at the screen looked white until you placed a solid object in front of the light and it cast a shadow. And each one of those lights cast a different color shadow. The different color shadows, when placed on top of each other, gives you a black shadow, because there were always shadows to begin with. The shadows aren't the light. The light is the light. The light that comes, the photons that are coming from the actual devices, that's the light that's coming out. The black that we saw on the screen was the shadows of your hand, whatever the hell you got in your hand. We saw the shadow of the lamp on the wall. We could see the shadows, and each one of those colors casts a different color shadow. They're shadows. When you mix colors, when you mix red on top of blue, you're gonna get purple. That's a darker shade. If you mix green with it, it's gonna turn a grayish brown color, which is what we saw when we looked at that screen and we saw the object casting the shadow. The shadow wasn't completely black. The shadow was translucent because it's not actually black. It's actually gray or brown or whatever a chromatic color that it projects. That was not even solid black. Black isn't translucent. Black is black. You can't see through black. And if you can see through it black, then that means it's not true black. So again, when we look at the shadows, you're seeing shadows being projected by three different light sources. Those shadows is only coming from a solid object that's obscuring the path of the light. We saw shadows, brother. It's that simple.
Okay, now what I want the audience to do, huh? Yeah, what I want the audience to do is go look. Yeah, what I want the audience to do, just go Google.
It was.
I'm
gonna take a picture.
Because what you saw, Karima, what Karima,
I'm gonna take a picture of it so you can see it. I'm about to pull up the picture so you can see it. I'm gonna show you. I'm gonna show you. I'm gonna show you.
Karima, what you saw was the blending of the cyan, magenta, yellow. And this one gonna tell the audience. Go look at what's called, just say, additive and subtractive color. And when you see cyan, magenta, and yellow together, once it comes to a focal point, that's when you get the color black. Because it has to first come to a focal point where all three come together in unison. So what he's saying is you don't see a black screen because they have not come to a focal point yet. And from the focal point, then that's when when the focal point reverses itself, then you get the cyan, magenta, and yellow color. So what he's trying to do is be disingenuous by saying, how come the screen was not black? Because it had not come to a focal point. And with Karima, what you saw was the three shadows, when they came to a focal point, all came to one. And that's not a shadow. That's black light. That he wants to call it a shadow. That's not a shadow. Once again, when you bring those three, cyan, magenta, and yellow, to a focal point, remember the word focal point. And when you go and look up on the primary color, and when you see them put those three together at a focal point, they'll show you black as the focal point. He's been disingenuous because he wants to try to use it in a broadcast. And he knows it's not going to be a black screen until it comes to a focal point. He's got an agenda, and I need to find out what it is. He's trying to stop black people. He's trying to stop black people from rising. That's what he's trying to do. He's trying to stop black people from rising. He don't recognize a rapture is taking place. He's gonna be left behind. We But going back to the objective of what I'm trying to do, make sure that black is now in the category of light. Every other color is in the category of light except for blackness. Because what it is, when they see black, they want us to think it's darkness. And if it's darkness, it's not connected then with the supreme intelligence. So my objective is to retire, reconnect, remarry black back to light so that we can understand who we are. Our nature is light. So we're going to be attracted to anything that really pertains to light. That's the reason Africa gave up all of her resource when somebody came with the knowledge what they believe to be God. Because when your nature's light, you're going to be attracted to light.
So I just put in the back chat, I just screenshotted where what we saw last night. This is the same shit. This ain't me photoshopping anything. This is what we saw last night. When you look in the back chat, you can see the yellow shadow, you can see the blue shadow, and you could see the darkness shadow of his arm and everything else, right? You can clearly see that those are the shadows of the objects that are in front of the light. Those are not lights. Those are shadows, and we can see them. And y'all, both of y'all sitting here telling us what we saw was not shadows.
I use a prism. I use the prism. The prism was a clear glass.
Okay, hold on. I understand that you use a prism, but what you need to understand is that the prism is still a solid object. The prism has corners on it, and when light, hold on, and when the light shines through those prisms, the light is bouncing around inside of the prism. So the shadow that's being cast. The shadow that's being cast is also being cast through the prism. And when it showed up on the wall, it showed up as what? A shadow. That's what it did. It showed us a shadow. No. Yeah. Yeah, I remember the image. Right. Okay. See, like when you look, let me zoom in on this right here. All right, well, go find that image for us, and I'm gonna show y'all this. Now this picture I just showed. This is the picture of the prism. This is the picture of the prism that he used. As you can see, the corner, the center line that's going in the middle is refracting the actual shadow being cast. Like you can see it when you see this blue part right here. That's a shadow. When you see that light yellowish color right there, that's a shadow. When these are all shadows. These aren't lights. These are shadows. You see what I'm saying? Because without the object in front of the light, it wouldn't cast a shadow, and all we would see is white light. Let me, right there, right here. Here, I found it. Watch this. Watch this. I'm gonna post it up. This is what you're talking about right here, Karima. When he had the object down and you saw that, that is still a shadow. That's the blue shadow. That's the red shadow. You know what I'm saying? And then you can see. And when all of those colors combine, it just produces a darker shadow. That's all it's doing. It's producing a darker shadow. The shadow isn't light.
The shadow, you have to have a background to capture certain aspects of light. That's you're saying a shadow, but it's the shadow of.
If that screen was black, we wouldn't have seen shit.
Okay, you have to have anytime you're looking at a prism, you have to have a background to capture the shadow. So when you capture
Brother, the background, that screen that you're using is not capturing that shit. It's reflecting that shit. That's why you can see it. That's why I said if the screen was black, you wouldn't have seen shit because it would have absorbed the light. It wouldn't have reflected anything. And not to mention when you shining that prism up there, it's light bouncing off the screen back into the prism.
I tell you what, you stay with your position, and I'll stay with mine, and Will's history will determine who's right. You really believe that you are expert on this information?
My observable reality. That's all.
Okay, like I say, as I get my PowerPoint presentation and present it to people who have a lot more information than what you have, because really you just want to be disagreeable. And so, once again, in order to capture light, you must have a background. That's the reason when they show it through the spectroscope, they have to have a background to capture it. You just can't capture light out of the air. You must have
shadows that we see.
You have to have a background to capture light. Then from the shadow, and how you then make it.
The screen that you used, was that a background that captured light?
Yes, it was a background that captured the light.
The screen reflects light. It's not absorbing light. It's not capturing anything. In fact, the light is bouncing off the screen, bouncing on the walls, bouncing on the prism, bouncing on your arm. It's not absorbing anything.
Okay. When I'm saying capture, that means that it has made it to that point and did not go through. It's not a translucent object. So the light now is, the word is incident. The light is not incident on that particular medium.
Bruh, this is the reason why I say that all people need a vocabulary lesson, because when you don't understand the words that you're using, it's hard for you to describe the reality in front of you.
But you still don't have the information.
You just use the word capture, and it's incorrect under the context that we talking. Because white reflects, it does not absorb. If it was being absorbed, then it's captured, right? Wouldn't you say that? Wouldn't you say that absorption is a type of capacity, a capacitor? Wouldn't you say that? Of course it is, because when black absorbs energy, it capacitates that energy and is translated over into thermal energy. That's how we know. That's how we know. That's the difference between belief and science. Science is repeatable over and over and over again, no matter who does it. This is what I'm saying. Like, it doesn't matter who does the experiments, because if you're getting the same results, you're gonna get the same results. You know what I'm saying?
Because I'm at work, I'm really not really engaged, and it may seem like your points are getting across, but I'm really not really engaged with you right now.
What you just showed us is exactly what I've been saying this whole time. That's a shadow.
That's not a shadow. That's not.
Okay, so if it's not a shadow, then why is it in the exact shape of the prism in your hand? I can see. That's because I've been showing the same thing. Karima, are you sitting here saying that prism in his hand is not cast? That's not a shadow being cast. That's right.
Okay. Let me ask you this. How could
I didn't have. That's because the whole time I've been sitting there saying it's a shadow.
Okay, here's the question. Here's the question. If it's a shadow, how do you produce a red shadow? How do you produce a yellow shadow?
With red
shadows are usually
yellow light.
That's what I'm saying. So if it's yellow light, then it's going to be the yellow shadow is the representative of the yellow light. And so when I took those three, that cyan shadow, that magenta shadow, and that yellow shadow, then how did that three shadows produce the black shadow?
Because the shadows, the three different color shadows are interfering with each other. They're blending together, which is creating a darker shadow.
Wait, whoa. See, now you lying. Now you lying. Now you lying.
Let me finish explaining. Let me finish explaining. When it's just a yellow light, you're only going to see the yellow. When it's a red light, you're only going to see the red. When it's a blue light, you're only going to see the blue. But the minute you put blue and red together, it's going to make a purplish color or a violet color. Okay. Once you put green and red together, it's going to make a type of grayish brown color, which is what we see in the background. That's what we see.
Okay. Let me ask you this. The yellow light, the yellow shadow, is that really yellow light?
It's possibly the red light.
Well, no. I'm asking about the yellow. The yellow shadow.
Yeah, the yellow light. The reason why we're seeing the yellow light.
No. Answer the question.
Let me answer.
Okay, it's just the yellow light.
Again, the reason why you're seeing the yellow light is because the red light and the green light are next to each other. The radiant color that is in the gradient color that is in between the red and the green is yellow. That's why.
That yellow shadow is that yellow light captured.
I just explained it, bro.
Okay, no. Okay, let me explain for the audience what he's saying. When you see the yellow light, that is a yellow shadow. When you see the magenta light, that is a magenta shadow. When you see the green, is it red, cyan, magenta? When you see the cyan light, that is a cyan shadow. So what he's saying is that the three shadows are three colors of light. And when I mix those three colors shadows together, then you came up with another shadow, which is called black. That was the black light. See, that's
it's not black.
See what he wants. He wants to be a shadow. So that's when you had to ask him. He's saying the yellow is yellow light.
Can we look at the shadow?
Let me finish.
That Karima just put up. Well, it's hard because
that's what he don't want to accept.
Because again, when you're talking about light illuminates, it radiates. What he's showing us is not a radiation. That's not radiation. That is light being obscured. That's what that is.
Okay, now once again, let's just go back to how. Once again, I'm not going to be able to get through to him. When you're looking at a yellow shadow, that is yellow light captured on the background. When you're looking at magenta light, that's a magenta shadow captured on the background. Because you just can't capture light in the air and do it. So you have to catch it on the background. So you have to catch the shadow. So you have to catch the shadow of the light on the background, and that's how you then determine the quality of the light. So when I capture cyan shadow, the red shadow, when I captured cyan shadow, the magenta shadow, and the yellow shadow, and blended those three shadows together, it then gave you a black shadow. And that black shadow was the black light.
That's because most shadows are black. And when you put red, green, and blue lights together,
I rest my case.
Hold on. When you put red, green, and blue lights together, it creates white. It creates white light. If you put an object in front of white light, it casts a black shadow. Duh.
I can present it to you, but I can't make you understand it.
Okay, so again, I'm gonna explain it again. When you put red, green, and blue light together, it creates white. The white light, when you put an object in front of it, will cast a dark shadow. That's the reason why we keep saying the darkness. Right here, this picture that he posted up of you holding that prism, I could see the shape of your hand. I could see the shape of the prism. And behind it on the screen is a dark shadow. And the only reason why we see a dark shadow is because the red, blue, and green light that is behind the fucking object is together is making a white light, which producing that dark shadow. That's the reason why. It's not because the shadow is light. It's not because the shadow is light. You're calling the shadow light.
I tell you what.
That's where the mistake is coming from when you keep on calling the damn shadow light. When you can't produce a shadow without light. You can't. Nigga, you can't produce, you cannot project that same color that's coming out, that's on that background, produce it through the lights. You can't, because you need an object to obscure the light in order to create a shadow.
I tell you what.
Never mind, go ahead, bro.
You stay where you are, I'm gonna present my information to other people, and then we'll determine at that point you're in the right place. Because once again, you can't hear it. I understand.
I can hear it when it makes sense.
Well, I'm not going to try to make it. I'm not going to try to make it make sense to you anymore. I'm not going to try to make it make sense to you anymore, because it's not going to ever make sense to you.
I mean, brother, it ain't never made sense to me, and it ain't gonna never make sense to me, because I'm a person that use colors, inks, and pigments. I'm a person who use lights, cameras, and action. I'm a person that use those things, so it ain't gonna never look like that to me. I'm a person that actually uses these things in practical applications. You don't use none of this stuff in practical applications. I've been using this shit for over 30 some odd years in practical applications, not just because it's something that I want to ponder on and theorize, because this is something I actually use and make money off of. This is the reason why I can sit here and tell you, like, no, brother, that's not our reality. You know what I'm saying? It's like me sitting here trying to tell you how to fix power lines when I don't work on power lines. You don't work in art. You don't work in graphic design. You don't. So you don't understand this shit. Just like you'll turn around and say you can take red out of black. You can't. You could do it on Photoshop because it's a digital program, but you can't do it in real life. In real life, you cannot extract red out of black. If you can, then that's not black. It's red. It's that simple. It's literally that fucking simple. It's not. This is not hard. And this like I could do an experiment right now and put red, green, blue, yellow. I could get all those different substances and I could put them motherfuckers together, and I guarantee you it's going to create a brownish gray color. I guarantee you. That's science, nigga. That is science. It's chemistry, nigga. That ain't got nothing to do with photons. That got something to do with me mixing this material with this material, and these two blends of these material gives me this color. You see what I'm saying? Just like right here in this picture, nigga, you needed the red, green, and blue light in order to produce this effect. And without those lights, you would have never had a shadow to begin with. This is the reason why you ain't just cast a shadow. You could have just cast a shadow and showed us that the shadow that I could take this prism, shine the shadow through the prism, and the colors are gonna separate on the other side of the prism, because the black light, the shadow is light, and this shadow going through this prism is refracting this light, and you can see the colors. That's how easy the experiment is. Take a shadow, cast it through a prism, and then put that projection on a background where we can see the colors. It's that simple. Take a shadow, not light. Take a shadow, shine the shadow through a prism. Wherever the light is refracted through the prism, it should show us a rainbow. It's that simple. Take a shadow, shine it through a prism, or I should say project it through a prism, and we ought to see the projection of all 7 colors on the background. This is what I mean by, if you're going to deal with science, you're going to have control groups. They're called control groups. If you don't have subject control groups, then you're basing everything off of one control group. That's not how science works. You need several control groups to come to the conclusion of one fucking idea. You think they created all these electromagnetic devices and shit by doing a one run test by doing it one time. No, they did that shit hundreds and hundreds of times, maybe thousands of times before they actually came up with what they actually wanted and what they actually wanted to observe. And I'm saying the same thing to you. This one experiment, great, that's cool. Where's the other ones where you could test your data against your theory? Right now, all you're doing is what you're doing is confirmation bias. That's confirmation bias. You don't even have any other control groups.
Okay, as I said, as I now am learning the PowerPoint aspect of it, and I get my equipment together.
What PowerPoint got to do with about a control group, not having proper control groups? Do you not understand? In the experiment, you have to have control groups.
But I'm not going back and forth with him that because I'm already sure. I'm already sure on the black light part, so I don't have to. But he just won't get it. But when I do the PowerPoint and I have my equipment set up the right way, so somebody won't have to then say, "Well, that was a shadow." I had to pick up my laptop and try to hold it with one hand, so all of that will be when I do it the next time, it won't be any mistake. It won't be any conversation because once again, I'm trying to hold a laptop, trying to hold this and hold that. Had I had somebody there to look at all the different sides and not been under a time restraint, you will see exactly what I'm saying. So once again, this presentation helped me a lot because I learned a lot of information about certain things I'm going to research. I didn't even know this was out here. I didn't know this. So once again, when I come back, I'm coming back as Superman, Black Superman. So your argument, huh? Oh, I got called to work. I'm at work right now, so I'm doing. Yeah, well, I'm saying, well, I don't have any information
Let me
with me.
hop on real quick. I got.
Okay.
Man, like this is the reason why Kamal was constantly asking for experiments and things of that nature, because with experiments you got control groups, and you can see how data is collected and how data is compared when you're using control groups. If you're using this one thing, then you're gonna have confirmation bias. It's just like when you research a topic. Yeah. So it's the same thing when you like if you're doing like any type of in-depth study, right? If you're only studying to confirm what you believe, that's the only thing you're ever gonna find. But when you study in order to know, you're gonna put all of the things in front of you, all of the subjects in front of you, and you're gonna study each one. You're gonna do the compare, contrast. You know what I'm saying? You're gonna do that.
What's up, girl?
Hey, what's going on? I just popped in. I don't know what's going on.
Yeah, they having a aftermath discussion over the debate from
Oh, okay.
yeah, and I'm just basically trying to let him, be able to reiterate his information. I know he didn't have that much time because they shorten it, and that be sometimes a
Well,
problem when they shorten the
no, it
time.
was him. I think really, I feel like in regards to the information, we, us, well, me being a judge, I feel like everything should have been in order. he, the fumbling
Yeah,
around,
no, we're not talking about that. We not talking about
just
that.
the information.
We're not talking about, yeah, we're not talking about the order. We're not talking about who judge and none of that. We're not doing that. We just giving them opportunity to break it down because it was late. So we had to
Yeah, and
shorten
shorted, and he had to
everybody's
shorten it
information.
5 minutes,
Yeah, we
five
had to,
minutes per
yeah,
session.
let
Yeah,
me explain. Let me explain. We have to shorten everybody's information. So this is
yeah.
what I'm trying to allow the brother to get it out, not with no, debate conversation and no debate argument or no, somebody just going against him because it's, you know what I mean? That already happened yesterday. So at the end
Right.
of the day, I'm just allowing him and Ruben because it's an aftermath. You know what I mean? So at the
Oh,
end of the
okay.
day, because and like I said, they didn't get their information out because we shortened the times. You know what I mean? And it wasn't their fault or nothing like that, but they did have a lot of information. So at the end of the day, this is an opportunity to be able to reiterate it and bring out information that they couldn't bring out then. What is so hard? What's wrong with that?
Who
So
you talking to?
no, I'm talking to just in general. You feel me? What's so hard
Okay.
about
No,
allowing?
I didn't
Not
know
you,
nothing
not
about
you,
that. My
not you,
phone
not
just
you,
rang.
not you. You just jumped in, so you don't know anything. So I'm
So,
just
Yeah, I'm just like,
allow
but this
him.
is, I'm
Allow.
good. I'm good. I'm willing to look at the information
Yeah,
and learn because it was compact. We started a little bit
it
late.
was. Yeah, we did, and we
Yeah,
shortened
so we
the time.
wasn't able to get everything. They had to
Right,
kind of skip through a lot,
right,
and everything was shortened, so they
right.
really couldn't get all of their explanations out in a timely manner because
That's
everything
right.
was shortened by 10 minutes. I mean, 5 minutes
5 minutes.
each round.
Yes, and that's a lot of information. And like I said,
Yeah,
when we got off that call, we all was on the after we got off the debate, we all was on the call and we all understood that that man couldn't articulate and bring out his information like we
yeah,
wanted.
yeah, yeah, yeah,
We
yeah,
knew
yeah,
that.
yeah, yeah.
We knew that. So at the end of the day, instead of just waking up today, you feel me, you know what I mean, going back and forth, you feel me, on the same thing. Let the man bring out the information. Ain't nobody winning nothing or losing anything. It's just basically letting them be able to bring out the information that he couldn't bring out.
Education. There's no losers in education,
Right. So because it'll be hard for us to you know, get the
and Daryl has to understand as well. A lot of brains have already been articulated to what it is because we were taught certain things in
right.
school. We
Like
was taught certain things in regards to our families. They presented certain things to us in a different way, which was the way that they was taught. But what I also want to say is truth don't change though. Information is always going to be the way that if it's experimented, it's always going to be the same if those same things are done. Now if there's some different entities that's involved in that, the experiment will be changed, but if not, it's always going to be the same. There's nothing really new under the sun, you know what I mean? So I think that's one of the reasons why the new information that he's given, he's going to have to really prove that information. um, and the depiction yesterday, in my opinion, did not prove that. So I would be happy to give him the opportunity to show something different or to reiterate the information that he saw. I mean that he presented, because the information that he's presented yesterday did not basically wrap around what he was trying to say. I did not see that with what he was trying to give. So it would be good for him to be able to reiterate that information. So not just the judges, but the individuals that he's teaching, which is all of us, will be able to understand what he was saying. Because the information that he presented yesterday did not prove his point. It proved the opposite of his point. So I want to see what he has to say as well.
so this right here is the same setup that he tried to display last night. You see the red, green, and blue lights.
Yes, sir.
This is these are actual real experiments that anybody can do, if you understand what's happening. So we just gonna flow through the information. It says a red, green, blue bulb shining simultaneously on a screen produces white light. Yes, you see that? Simultaneously produces white light. That's what we saw. This is the reason why I asked them, like, hey, how come the screen wasn't black if it's producing black light? It's producing white. That's what we saw. Before you put an object in front of it, all we saw was white light. It says, since the bulbs are displaced from each other along a horizontal axis, placing an object in the light path blocks the light from each bulb on a different region of the screen, and thus produces overlapping cyan, magenta, and yellow shadows. Notice that it's calling it yellow, the cyan,
a shadow, because black is a shade.
That's
Black
what
is
I
not a
kept saying.
color.
These are shadows. These are not lights. They're shadows. It says which where they overlap leave shadows of individual colors, red, green, and blue, and of course black where all three overlap. So again, where all three overlap, you're going to see the black shadow. This is the same thing I have been saying, but in my own words. It says the human eye sees colors by the means of three types of cones in the retina. These cone cells have pigments whose absorption maxima are approximately 560 nanos to 533 nanos to 430 nanos, which is red, green, and blue. I have put these colors in quotes because while they give the relative position of these absorption maximas within the visible spectrum, they do not necessarily correspond accurately to colors that we see for monochromatic lights of wavelength. They also probably do not correspond to the colors we would see if only one kind of receptor was stimulated. So they're talking about in your eyes. They're saying if one,
your corner,
right? It says each in turn for light of a given wavelength or mixture of wavelengths. The color we see depends on the relative response of the three types of cones. Any combination of light that will stimulate all three cones roughly equally appears white. It says if we shine a red light source, a green light source, and a blue light source so that their beams overlap, the regions where they overlap will appear white. While the color floodlights on the board in the photograph are not aimed at the same spot, the overlapping beams is sufficient to illustrate the effect of mixing all three colors to obtain white. We can also observe that the mixing of these lights two at a time is shown in the photographs below. So this is what they're talking about. It says here, all three lights are shining on the screen, facing the screen. The red lamp is on the left, the green is in the middle, the blue is on the right. What we see in the center of the screen are all three overlapping beams, white. That's what we see right here, white. It says when we unscrew the red floodlight, leaving only the blue and green, we see effectively white minus red, which gives us the turquoise in some books. You see this? It's a turquoise because they took out the red light, right? It says when we remove the green light and we leave the red and blue, this gives white minus green or magenta or purple in some books. See this right here? This is the magenta. It says when we remove the blue light, leaving the red and green light, we get white minus blue or yellow, and that's what you see right here. Now it says when you place your hand in front of a screen like he did, for the reasons noted above, it casts a set of three overlapping shadows. Notice it's calling them shadows. They're not light. It says which give each one giving the color shown above. In the photograph at the right, we clearly see the yellow shadows where the blue light has been blocked, magenta shadows where the green has been blocked, the cyan shadows where the red has been blocked. Where pairs of these shadows overlap, They leave red, blue, and green, and where they overlap, of course, we see no color, black. You see, this is the same. This is the same exact. This is the same exact experiment. They just went a little bit more in depth. They gave us a little bit more information than he did, but it's the same experiment. The only difference is they're not calling shadows light. They're clearly telling you that
They're shades. Black is a shade and white is a shade.
Yeah, white and black are shades.
Yeah, but they is kind of calling it both at the same time. I ain't gonna skip past that. They saying the red light, the blue light. They still calling it lights, but then they call it shadows at the same time. But you see, it's saying light too.
It only becomes a shadow once you obscure the light with an object.
Yeah, it's not a shadow, it's a shade. That's what I'm seeing from, because I was doing some studying as well, just by myself, just not with the group or anything like that. With my son, who's in college for physics. So he goes right now. He's at Grambling. So I was talking to him about that, and he was basically saying the same thing as New World Order was saying in regards to the black. The black has no substance in it. There's no energy. It just takes. It don't push out.
Right.
So that's how he explained it to me. But of course, additional information and being able to see it for yourself and experiment, you see things with your own eyes. So I asked my son, what about a black light? Because I got a black light in my room, right? They call it a black light. This black light illuminates all other colors, right? It makes shit glow. You know, it brings, the room is dark, but it basically illuminates other colors, right? My black light that I have. So if I turn off all my lights, and everything is dark, but they still colors. When I turn on my black light, those other colors illuminate. So I was asking my son, if there is no black light, why the hell I got one? Right? Why do they call this light literally a black light? And this black light that I have illuminates other light. Other colors, right? So if I got white on, even, you can see that there's white within the darkness. When I turn on the black light, it illuminates that white. It brings that white out. It illuminates any color that I have on, anything in my room. The only thing it don't illuminate, because it's black itself, is black.
Right.
It does not illuminate black. You will not see the black. You just see everything in the color. So let me show you guys something. And it's daytime, so I won't be able to show you really, but this is what I have in my bedroom, right? Let me turn it around so you guys can see it. Hold on, let me turn it around so you guys can see it. Or maybe I could just turn my phone around. Hold on. But you see me. Now this is a picture that's in my room. You see all these colors of this plant? This is a weed plant. This is on my wall, right? I got a black light that I put on this plant at night. And you see how you see the colors? But see the black light, all this around it, right here, you don't see none of that, but it illuminates. I'm talking about this right here actually glows.
Yeah, that's because those the paint or whatever dye substance that is using, the UV light is actually bouncing off of that and is giving a glowing effect. You see what I'm saying? Because
yeah, that's what I'm saying. But that's what I'm saying. But how could that black light? It's a UV light, but it's still a light.
Right.
It brings out these colors. Right. It literally illuminates. These other colors. But the only thing it will not illuminate is the black. The black is the only thing that will not show any type of color at all. It don't bring any reflection. It don't bring nothing. It's just black. So that's the only thing that really makes me want to dig deeper into what Joel is saying, because I literally have a black light that illuminates other colors. It doesn't have any illumination itself, but it actually brings out other colors. And I know that from just living, just me having a black light, just me having black lights in my weed, right here, in my tent. I got a weed tent, right? In my tent to get darker yields, which is purple weed,
Right.
you know, darker condensed weed. I use that black light.
Yeah.
So those other lights, they bring out more of a fluffier marijuana plant, like a lighter color, but things do grow. See, so this is what I'm saying. In that black light, plants need light to grow. My weed is more potent and it grows like crazy with that black light.
Yeah, because it's UV.
Yeah, so that's what I'm saying. So black is light.
No, it's not.
Well, how does my plants grow and yield to 7 feet tall in a tent with a black light then?
Because first of all, they're just calling it black light. It's not a black light. That the color, in fact they can make that any color. They can make that red, they can make it green, they can make it yellow, they can make it any color.
I do have that now. For the regular yield, I have what they call an ultra light. So this ultra light, let me show y'all. Let me show you my class right quick. I don't want to put all y'all in my business because I do a lot of stuff. But
your plant, that weed plant, is absorbing that ultraviolet light and then being re-emitted at a different wavelength. That's what makes it look like it's glowing. You see what I'm saying? Now the black.
No, I'm not talking about the weed plant symbolism that I have on the wall in my room. I'm talking about my actual plants that's in this tent right here.
Yeah,
you know what I'm saying? That's what I do is, what I do is I got one light, right? If like everybody can know that you got a class, right? But I'm gonna show you something on what kind of lights different colors bring in regards to growing plants, right?
Yeah,
because I put a red light in there.
Myself.
So you put a red light in there, you know that is for when you already did your 7 weeks. You know that's not the first light you put on there for that type of growth. The first light you're gonna put on there is a white light.
Yeah, because the white light got all of got the whole
the spectrums in it. Right?
And then you use the red lights are specific for certain
weeks. Yes.
Stages of the plant. So
correct.
Like, when the plant is going through flowering stage, you want a specific
correct. Now that's exactly what I was getting at.
Promote flower growth. You see,
but look, at the end of it, right? When we really want our buds to get hard, we want our buds to get green. We keep that thing dark, man. We put that black light up in there. We keep everything dark and cool.
Yeah.
Because see, look, the light itself, we think that the light itself, the black light don't get hot like the rest of the lights. The black light actually get hotter than the rest of the lights. Literally, it's not in regards to this experiment. This is what I do. This in regards to life. You see, I already got my tent. My tent been here for years. Every season we yield in, you know what I'm saying, at least 6 plants. So this is what I'm saying. These plants grow with this black light. They actually yield. They don't grow like up, like tall, but they get like nutrients and they get you from that black light, and that light is a light because it's still growing.
Yeah, but
that's all I'm saying.
They just call it a black light. It's not black light. It's UV light, and UV.
Okay. What is UV? Is UV black?
No. UV is completely invisible to the human eye.
Right, but
they
that's what I'm saying. It's
assign
invisible,
colors.
but it's still making my plant grow.
Yeah,
So
yeah,
it must
it's
be some
invisible.
sort of light. That's all I'm saying.
Well, yeah. All of the spectrum is light, from radio to gamma. It's all light. From infrared to gamma, it's all light.
Well, that's what he was saying. The only thing he was saying is black is light.
No. It's not the same thing. What he's saying is the color black. That's
The same as X-ray in the electromagnetic wavelength.
Which is wrong, because you can't see X-rays, but you can see black, which means they don't have the same wavelength.
Okay. Well, I just wanted to just put that out there to you guys in the audience, how I deal with black light or a black, and how it illuminates different things with my black light. You know, we like, you know, we come from you know what I'm talking about. We be zoning, so we like the LED lights in the room, and you know, we know that certain lights hit your neural, which is your brain and your eyes, and they do different things. If you got LED lights in your room all day, every day, they tell you these lights may cause seizures. These colors, the information of these colors may cause that, but black don't cause that. Only these different type of colors who have different type of wavelengths that can go to your brain and basically mess with your neurals. These specific colors. That's why when a person has seizures and stuff like that, they have to be in soft color rooms. They can't be in no other because they give them seizures.
Yeah, and I want to add on to what you were saying, is because they have what you call a photo, like you could take infrared light, right, and and the infrared spectrum, and you can use that to heal yourself. You can bathe yourself in infrared light at a certain nanometer, and it will actually heal your skin and penetrate down to the bones. This is the reason why we know, like in their medical practices, they
like that laser. They do that with that laser. They do it with laser. Correct. I just had surgery, so I do know that what you're saying is true, because they use that technology on me to open up my belly. I had a hysterectomy. They took all my ovaries and everything out.
They do that to all black women.
Right? Yeah, they come for us, right?
Yeah.
So they took it out. But when they took it out, for one, I asked for my placenta. You're not taking my shit. Right? We got a placenta downstairs of mine in the freezer. You know, kids asking like, what's going on? Because they don't have the right to take that from you. That's yours.
You're supposed to eat
and unless you sign it away, you know what I'm saying? It belongs to you. Don't give your shit to white people so they can eat it. Anyway, off that.
They're going to eat it. That's exactly
what they eat it. They eat it. It's a delicacy for them.
Yeah, well, I mean, it's a superfood. It's a superfood.
Yeah, it is. It is. But off of that and back onto the subject matter.
Right.
The subject, the reason that I brought that up is because before the surgery, they give you the steps on what they gonna do and how they gonna do it, right? And this surgery was with the laser, so they call it endoscopy. Endoscopy, ENDOSCOPY. That's what they call this type with the laser, right? When they going in. Okay, I got the paperwork right here. I'm looking at it. What they did was they get red infrared laser. You ain't getting cut with no knife, no nothing. This red light makes persist incisions, like perfect incisions. They can do, and it goes all the way as far as they want. Okay, so they can go on the top and just put the length, and it'll go directly straight through all the way to your bone, just like that. Just like this gentleman just now said, cut whatever they want to dislodge.
Yep.
And then they get another one, right, to seal it off. So they got one. The red one cuts everything. That just goes through everything. And then they have another one with a different type of tool that basically seals it up.
Yep.
right? So with that, we know that specific colors have more power, literally, than other colors. That's why there's prime colors, subprime colors, and shades. Now I'm gonna go ahead and yield on that and let you present the information.
Don't get me wrong, shade is very important. Like you know what I'm saying? Because we wouldn't have mushrooms in the fungi kingdom if it wasn't for darkness. You know what I'm saying? Because that's
what I know for. Let me tell you something. I know for a fact. At the last 2 weeks of your yield, you cannot just not put no light in your. I don't know if people do outdoor. I do indoor though.
Yeah.
You cannot put nothing in there. You have to put your fan in there so everything in there can move around, or else you about to get some mold.
Yep.
And you gotta put your light in there, the black light. We like gas. We from California, so in order to get that weed dark and to get that purple on there, it gotta stay dark with that black light. Now, if the black light is not light, how is the weed still yielding? How is it still formulate? Because you can't formulate without no light.
It's not black like the UV is invisible. They just assign colors to it. They could have made that.
So UV would be considered black light.
No, it's not. It's not actually black. They're just calling it black. It's not black.
Okay, so what is it? Because when I see this light, it's literally black, bro.
It's outside of the human visual perception, so you can't see it. That's why we assign colors to it.
But you can't see it, but that don't mean you can't see Christ. But that don't mean it's not there. Because you don't see it, don't mean that it's not there. You don't see really air unless it got dirt and all that in it. But you know that air is here though. So I look at this as the same thing. The only reason why I voted against Daryl last night is because of the way that he presented the information. He kept kind of going around in circles. But if you present the information the way that I see the information, because I deal with that, and I had to call my son to ask him about that, right? But there was really no reason for me to ask nobody when I sit right here in my bed. I got this weed playing my thing, and there's a light above there that I could click on, you know what I'm saying? So I could vibe at night and everything glowing up in here, you know what I'm saying? It's literally pushing out a light. It's illuminating everything else in my room.
Yes.
And then when I put my black light in my tent at the end for the last 7 years, I put that black. I get fire. I get good yields, hard.
If I'm not
good, condensed, solid, dope. Literally.
You shouldn't sleep on the blue light because it's actually damaging to you.
Oh, I don't sleep. I don't sleep under the blue light. I don't even sleep under the black light. You know, sometimes I just vibe with it. You know, at the end of the night, I vibe. You know,
that red light though. You could sleep under that, and you're gonna wake up a little bit more refreshed than you usually are because the red light sends your body through a healing state. You know what I'm saying?
Well, what I do instead of doing that, I don't do the light. What I do is listen to frequencies at night. The frequencies put me to sleep. 956 megahertz of frequency. That's what I do.
Yeah,
and that regenerates what's going on within my body. It gives me
to make sure.
So that's a whole different subject matter as well. Frequencies, well, kind of, sort of, but frequencies and light, you know what I'm saying, is a little something different, but I deal with frequencies as well, different frequencies as well, and what those frequencies could do to your body as well, rejuvenation and stuff like that, you know, in regards to frequencies. So that's why I was kind of listening to Daryl too, and both of these really New World Order as well, in regards to what is the length, right? What is the length between this power? Because sometimes you have a wavelength that could go heck of far. And then you have other colors that have a wavelength that don't do shit, which is black. So I want to know if the wavelength of black really don't do nothing because black absorb. How does it push out light? Because it does push out light, even though we don't see it. It has to do something because my plant's still growing.
Yeah, like again, being in darkness is actually healthy because it gives your system time to power down and recorrect itself. Because while you up moving and talking,
The black light has something to do with photosynthesis, bro. Period.
Well, when you talking about black light, you talking about UV and the sun.
So that just shows, but you keep saying you talking about black light, you talking about UV. So that means that there is black light, and it's called UV. If you just telling me that, that means that the black light that I refer to is called UV. That's maybe what we considering as the black light, UV.
No,
because it is.
So you could consider it whatever you like, but it's not black. Because you can see black, you cannot see UV. It's invisible to the human eye. It's not black. You can see it.
I agree to disagree on that.
Black. We can all agree that we can see black. If you can see it, it's not UV because we can't see UV. Just like we can't see radio, we can't see microwave, we can't see gamma. The only light that we can see is the visible portion of the light spectrum.
The primary colors, the colors that hit the back of your retina, the colors that, see, you have to understand, for one, the front of your eyeball is not even the what's seeing it. It depends on your brain capacity and what's in there in regards to the colors, okay? Because the light hits the back of your retina. Your retina gives your brain the information, and then that information goes out to your eyeball for sight to say what you see. The parts of your brain control the way you think, your vision, your hearing, all that parts of your brain. So therefore, I think that it depends on the capacity. If you looking at 3 prime colors, because no matter what, we all agree, scientists agree that there's 3 prime colors, right? And them other colors are subsidies of those colors, or just blatantly disregarded as shade. Which means that if you add these colors or take away these colors, you're gonna get something different, right? So what I'm looking at is, how could black not be light? That's all I'm trying to say. How can black not be light? Even if it doesn't have anything in the spectrum, is there?
Because the reason why
is it there if it's not, if it's not, and I see it used?
Because black absorbs light. Black absorbs electromagnetic energy. That's why.
Yes, it does. Okay.
You see what I'm saying? So that is the reason why black can't be a light, because light projects outward. It projects.
Okay, so what's growing in plants then?
When you're talking about UV, the actual frequency of UV is what the plants is using.
Okay, so UV is black, and UV is light. That's what I'm gonna go with, and I'm gonna sit down because that's what I'm getting to, and that's what you're saying. But you're trying to say it to where I don't take it like that, but I'm taking it like that because that's what I see.
What I'm saying is the UV lights can be any colors: red, violet, blue, green, orange, yellow. They could be any color.
Right, but this is what I'm telling you. None of them work though. Because let me show you these lights. Let me show you these lights. Let me show you my own little, because they're not like y'all lights.
Yeah.
But this is a different light. I don't think I got a blue one. Hold on, let me see.
When you talk about UV lights, you're talking about a specific wavelength of light. When they assign colors to it, they're only assigning colors to it because it's invisible to the human eye. Without them assigning colors, you wouldn't see anything. You understand what I'm saying?
I do got it. Okay, so this one right here, let me show you. Hold on, let me see. Because I like to go here. So this one right here, hold on, y'all, let me just turn this. This one right here, right? See this box? You see it? Okay, it say, you see where it has the optimal growth at right here.
Right.
Could y'all see that?
Right. In the yellow red
And
spectrum.
see, you see where the larger colors that we said was prime colors are larger. And then at the end right here, you see like a purple, right? But right here is black. 0 is black.
Yeah, 0 because there's no wavelength frequency.
Right, but I do see that 0 is black. It is there, and it is black.
So if there's
And
no
you see what it
wavelength,
says? It says germinal grow, average grow, and maintenance grow on different ones. Now this color, this light, hold on. Now this is for, okay, so this is a white light. This is for the white light. You see that?
yeah, it's a sodium bulb, right?
Right. So
Right.
that's right there. Hold on 1 second. Let me see if I can get the blue one and what the blue one and the red one say.
Right. So they could assign any colors to those UV lights. The color does not matter as much as the actual frequency of the UV light. And I'm trying to share this screen so we can actually learn a little bit more about the different variations of UV. Because you got UVA, UVB, UVC. You know what I'm saying? And
Oh, okay. Well, let me know something. Teach me something because last night after I got off the phone, I was thinking, and I'm laying there under my black light, looking at that weed plant on my wall, and I'm like, hold on, it's this shit. Why is this illuminating then? If there's no light, and then I'm looking at how my weed grow. You know what? Like, you know, at the end. That black, I'm telling you, that darkness and that the coolness, that fan and that black light is what do it.
This right here is if you can see on the screen, it says
UVA
for you and your plants. Now this top one, it says UVA. UVA is a part of the plant's natural environment. It does not damage the plant's DNA. MAP boosts cannabinoid content. It says when introduced at the right time, UVA may enhance certain properties. Most grow lights emit some UVA, a valuable addition for indoor growing, not filtered by ozone layer or glass windows. Least dangerous UV wavelength may lead to skin cancer. Excessive exposure may increase the risk of skin cancer or X-melanoma. It says 98.7% of UV light hitting the earth is UVA. Sunscreen protects against UVA. This is UVB. UVB may boost colors, terpenes, and more naturally protect against microorganisms. Now, you remember during COVID, they were using the UV lights to
clean.
Right.
Yeah, because I have me and Kareem, we both have cleaning companies. So we would do is we would use that UV light. That it was blue though. That UV light that we use is blue.
They do the blue. They have to assign a color to it, or else you wouldn't know that it's working because it's invisible. So you wouldn't even know that it is working. So they have to assign a color to it. So your eyes can pick it up. You wouldn't even know if it sterilized that area. You know what I'm saying? The only way you can see it is because they assigned a color to it. It says for long-term intense exposure is still harmful. When introduced at the right time, UVB may enhance the product. Each plant species react differently to UVB exposure. Most grow lights emit some UVB, the valuable addition for indoor growing. It says crucial to vitamin D production. Long-term intense exposures can still lead to skin cancer. Sunscreen protects against UV. Humans need UVB to survive, but protection against long-term exposure required. Long-term exposure leads to skin cancer and the signs of aging. 1.3% of the light hitting the earth is UVB. Now,
that's the light from the sun, right?
Yeah. Well,
that's not artificial light, is it? Because artificial light and light from the sun have different qualities. Artificial light does not carry vitamin D.
Like the sun produces all of these, but at different quantities. It says, It says not required for plant growth. So they're talking about UVC. It says it quickly damages plants' DNA. Grow lights do not emit UVC. It says 0% of the UVC light reaches the surface of the earth. Even short-term exposure can damage plant. UVC may be useful for sterilization in grow rooms. Highly dangerous to humans, causes lesions, burns, and
Yeah, that's why you got to put them gloves on, them plastic gloves, and them glasses on when you clean the rooms that got the UV
it says
and the foil inside of it.
sunscreen
Yeah.
does not protect against UVC. Short bursts of exposure may cause irreversible damage to the skin, and that's right because the proper ultraviolet light can strip or unravel your DNA. You see what I'm saying? So this is the reason why they got to use the specific.
And once that gets unraveled, that's where cancer comes in at. So yes, I do understand that part.
That should have aged the fuck out of your ass.
Yeah, and not just that, it causes cancer. So I understand that part, but I'm still challenged with, well, really not really now, because you just explained there's different aspects of that UV ray. There's different aspects of different types. So in regards to black having the same qualities as the electromagnetic forces, that wavelength, for one, the wavelength. Black has no wavelength, and an X-ray has a bunch of wavelengths. So that right there is one difference altogether.
You can see it right here on this.
Yeah, I know. I looked that information up. An X-ray machine has a bunch of wavelengths.
Yeah, you can
and
see
black
it right
has none.
here.
So that right there was the first thing to debunk the situation, to say in regards to this. Now, in regards to it being light, that's a whole thing. That's a different thing. But in regards to an X-ray machine, I feel like this whole situation should have been stopped from the beginning, because we know that the X-ray has a real high frequency and black has none.
Right. Like we
So
can see
that debunked the whole thing already. But
you can see in this graph right here that the X-ray portion, you see that the squiggly line above the X-ray. Okay.
Yeah, that's how many wavelengths.
Yeah, that's the oscillating frequency of that
Right.
wave. Right. Okay. Well, black would be
Has
zero. It
I know that. I see that. Yeah, I see that. So that we know for sure in regards to the debate, does black have the same electromagnetic wavelength as an X-ray? And the answer is no, it does not. Now, if you go now, that debate is over with. Now, if you want to prove that black is light, you're gonna have to prove that and prove that you can get wavelengths within black.
And that's the reason why Kamai asked the brother, okay, what method did you use to determine that black has a wavelength?
It has no wavelength. That's a fact.
To measure the wavelength of black, what machine or device did you use to determine the wavelength of X-rays to say that black and X-rays share the same wavelength?
Well, it's just this general information. You can look up the information on what's the wavelength of an X-ray and what's the X-ray. What's the wavelength of a black? It's just the color black.
But for a person that's saying that black and X-rays share the same wavelength, that person would have to at least add an experiment or an equation that we can follow, or some type of methodology that we can follow that will say, hey, this is the wavelength of black, this is the wavelength of X-ray.
Correct. That was unable to be proven because you can't prove it. And he knew that. That's why he asked him to prove it and to put a experiment up there in regards to that.
Yeah. And that's
why he did that. That's why his closing ended with that, because that was basically the nail in the coffin. Okay. You can't prove it because it's not there. The black does not have any wavelengths. We know that. But is black light? Even without those wavelengths, is black light? So that should have been the question of the debate.
It
shouldn't have been black being the same wavelength, because it has no wavelength. as an X-ray. X-ray has high wavelength. So it should have been, the question of the debate should have been, is black light?
It is the issue will come when you understand what light is. And when you understand that photons are traveling electromagnetic fields, you have to understand that a photon is a traveling electromagnetic field. And then
yes, I understand that.
Right. Okay. So
a photon and a neutron, we
absorbs all electromagnetic radiation.
Oh, I didn't know that. See,
you see what I'm saying? So because black is absorbing all electromagnetic radiation, it cannot be light, because light projects outward because it's traveling.
Yes, it is. One goes in. My son said that one gets light and one pushes off light. That's how my son explained it. He said black gets light and sucks it in, and white pushes light out. It gives like a reflection, a ray outside, outward, and the other one is just sucking it inward. That's how my son said it.
Saying about the experiment that he showed, the light that was coming from those 3 lights that he was shining, those lights hit the screen, but the screen is reflecting light, so it's also
because it's white.
Back. It's
right because it's white.
Towards his arm, towards the prism,
right?
Light back to it. So you have different interference patterns happening because the light
and the surface itself was a reflective surface, white.
Right.
Yeah, and that's what I seen too. That he pulled down a white surface.
And that's the reason why I said brother needs more control groups. You know what I'm saying? Yeah. One with a white screen, one with a black screen.
With a black screen, yes.
One with a red screen, a green screen. You got to have different control groups so you can falsify the information that you have or that you believe in. You know what I'm saying?
Right. I did notice that the first thing that I noticed is that he's putting those colors on white, and white naturally just reflects. So it's going to reflect that shadow because it's white.
Yeah, it reflects, and this
light,
is the reason why I said if he would have made that background black, we wouldn't have seen shit.
Right.
Because the black.
Right. So that's why. But you have to understand too, Duro, he will get to that. He just now starting. This was his first PowerPoint. Best and rest believe now that he know that we think like this, now that he know that he might need a black light to show and get his point across, I believe that he will do that. I believe that he will do that just to show what he is saying. By him already having that those prime colors just in his household. Because he went and got that from somewhere.
Yeah.
You know what I'm saying? And he didn't know that we was gonna put him to the test on this. So that means he's very interested and intrigued. So I really do feel that Duro will come back with some information to see. For us to show, but I don't feel like his information will ever show that black has the same wavelength, electromagnetic wavelength as an X-ray. That has been debunked. That's over with. He needs to come back to show in his way that black is some sort of light. Because what I'm seeing is that it does grow stuff. No matter what goes on, stuff. It may be in photosynthesis, like, some things, of course, light wakes us up. We think of light, up. We look as dark as sleep, slumber, no movement, no activity, right? And we know that any living mechanism needs both. It needs the light and the slumber to grow. Now, is it because it is that black is actually the slumber part of it? And if it is the slumber part of it, why can't I just leave my tent with no light at all, zip everything up, and turn on the fan and it still grow? That's all I want to know.
Yeah, man. Like when I've told him this before, is if he want to prove what he's saying, he's going to have to project a shadow, a solid shadow, through a prism, and then allow that prism to reflect the colors that is contained within that black. If what he's saying is true,
Right.
and this is an experiment. I just gave him an experiment. Project a shadow through a prism and allow the shadow to put the rainbow colors on the background. That's easy. That's something easy that he should be able to do if he's saying that black is light. You should be able to do it. Now, we know we can take white light and do it. Okay, so then you ought to be able to take this black shadow, because that's what we calling it. We're calling it a shadow. It's not a light.
Because it's a shade. It's not even a color. It's not one of the prime colors. So when you look up color, you don't see black. Black is not one of the prime colors.
Right.
You see these other colors that contribute to all these other basically semi-shades of those. So it's the ish of everything. It's the ish of everything, right? So this almost like saying I'm Jew and then I'm Jewish. It's a derivative of those colors. It's not actually that color. You know what I'm saying?
You can do the experiment yourself. You can go get paint. You can go get ink. And the minute that you add black,
I got paint. I got paint right now. My daughter an artist. Hold on. Let me see what you got. What colors y'all need?
Like if you take, let's say for instance you take red and black.
And I got a black plate too.
Look, if you take the red and the black paint and you mix them together, it's gonna create dark red.
Yeah, it's gonna be burgundy. It's just burgundy.
It is impossible for you to return that paint back to red and back to black. One is just black and one is red. It's going to be impossible because once them colors mix, it's dark red. It's dark red now because you added the black. The black made it dark. You know what I'm saying? And anybody can see this. You could take green and you could take blue and you could take yellow. Mix them together and it's going to be green. You are not going to be able to extract the yellow from it or the blue from it once you mix those colors. You're not going to be able to do it. You see what I'm saying? Because now it's green. Now it's a primary color, green. You see what I'm saying? You're not going to be able to separate yellow from the red. You're not going to be able to do it. You see what I'm saying? So, and this is what I was trying to explain to him. If I take red, blue, and green,
I think this would work with a little bit of dye. If we just got a drop of dye.
It don't matter what pigments you use. Once the pigments mix together, they create a whole other color. You see what I'm saying?
Your colors at.
You can't
extract I want to do an experiment
out of it. Now you could do it on Photoshop. You could do it on Photoshop because
what colors? Because my daughter an artist. I'm in her room. I'm trying to get some either a squeeze paint or a water paint.
Yeah, it don't matter which one.
Okay, hold on. Let me.
It don't
you
matter.
got red, yellow. Let me see what you got. Where them squeeze paints at? Those ones that I got you that was in the little tube thing. They all here. Okay. So what colors is it?
So when you mix red, green, and blue together, that shit's gonna make brown. It's gonna make it dark.
Okay, I got yellow. I got.
Depending on how dark your colors are, is gonna make that shade of brown.
Okay, so I'm about to get this. Let me get one of your canvases right quick.
Yeah,
no, the canvas is white though.
Yeah,
okay, so let me get let me get the top of one of your shoe boxes that's black. Let me get a top of your shoe box that's black, and then let me get one of them canvases.
Yeah, it don't matter which color the background is.
Oh, it don't? Okay, let me have one of them canvases then.
Yeah, it don't matter which color it is, because the chemical composition of the paint is what it is, and the background of it is not going to change the effect of the colors unless you thin the paint out with water. You have to thin the paint out with water or some type of acetone or something that's going to.
Oh yeah, that kind of that I know what you're talking about. That'll thin it out. Okay, let me go on downstairs so I can get
thin it out. Don't do nothing but make it translucent.
Right, make it like not as dark because it's been diluted.
Yeah, it's diluted. It's see-through, which is what I was telling him. Like, if you could see through that shit ain't black. Like
Okay, so this is what I got. This is what I got. I'm gonna
let us see. Let us see. Turn your camera on. Let us see.
Okay, hold on. Let me see. I'm gonna see this right here.
You could put the red, blue, and green together and mix them up, and that shit's gonna turn brown. Damn, she dropped off. This is gonna be interesting, bro. Cause like you know what I'm saying. This is what I mean by like anybody can do this shit. Like it don't take a science. It don't take no mathematician or nothing like that. This just takes somebody who willing to sit down and play with the shit to come up with a logical, definition of what they seeing. Like, so when she mixed those red, blue, and green together, that shit's gonna make brown. It's not gonna make black. It's gonna make brown. You know what I'm saying? Now you depending on how dark the blue, green, and red is, will determine how dark that brown is gonna be. You know what I'm saying? Because you could take pink, orange, and baby blue, and it's gonna make a beige color, which ain't nothing but a variation of brown.
Okay, so let's get the turtle color. Right. Let's see. We got black, and we got what colors? Okay, we have green.
Yeah, you can mix green, red, and blue.
Okay, green. Okay, let me get red. Do she got some reds in here? Okay, we got a blue. We got a whipped blue.
Yeah, it don't matter.
Blue. So here's green and here's blue, and we just need a red.
You can put one dot of each on the canvas and start mixing them together.
Okay, so what I'm gonna do? Okay, what is this? What color is this? We have red.
There you go.
Okay, so let's go ahead and
equal amount of.
And then we have a canvas. That's
okay.
Little tiny canvas. Hold on one second. So we're gonna do red, green, and blue. So let's start with the blue.
All right, use the same amount.
Okay, just a little.
Power in the other.
Okay, so just a little.
Just a little bit.
Okay.
All right, put the same
amount. Like that. Right, just a dot. And then we have the green.
The green. Try to get roughly the same amount.
I put a little bit more green than blue, so I'm gonna put a little bit more blue.
Well, it don't matter.
You see that?
It's blue and green, so it don't even matter.
No, come up a little bit. Bring your camera up a little. We can see the tip there.
All right, now throw the red in there.
Okay. Okay, so this is what we got. This is how it looks. You guys see it?
Yep.
You see it? So now I'm gonna get just a brush, a paintbrush, and then I'm gonna mix it together. Give me 1 second.
Now watch this turn a rich brown, like a chocolate.
So this has nothing on it. As you guys see, it's a paintbrush, the end of a paintbrush, no color. And we're just gonna mix it here. It's actually turning into like a brown.
Yeah, that's what it's gonna do. It's gonna turn into a brown or a type of grayish brown.
Yes.
Brown.
Hold on 1 second. It's turning into like a brown dark mass.
Yep.
So this is what I'm getting now. I did that, and you see the colors, and you see the red, you see brown. The green, you see that?
Yep, it turns brown.
Now, it is turned into a brown color.
Pull it up. Pull it up. We can't see it.
And you could actually see the red, the green.
Bring it up. Bring it up.
Bring it down. Yeah, you see right there. That's not black. That's brown. Right there. That's brown.
Yeah, it's a brown color for sure.
Now,
like a really dark.
Keeps mixing, right? It's gonna be completely uniform brown. And it is impossible for her to separate the green from that brown, the red from that brown, and the blue from that brown, because once you mix the colors, it becomes a whole nother color. It's brown now.
Right.
Even
It's not even, you can't, yeah, all these colors are pulled in within that color. Now let's see if I put red and I try to pull it out.
It's gonna make it a richer, redder brown.
So we want to see if we could pull them out. So hold on one second.
Well, if you gonna pull them out, you wouldn't add extra. You would extract the red.
Oh, can't extract it. Can't be extracted.
I have no idea how that process goes, because I've never.
Yeah, you can't extract it. It's done. Once it's there, I'm looking at. I just now mix it all together, and look how it looks.
Go down some more. Oh yeah. See, that's what I'm saying. It's that's what I say. It's this brownish, grayish color. You know what I'm saying? And this is the same thing that we see on the screen when all of those different lights came together. You see the polarization of all of those colors that gave you like this achromatic color, which is like a brown, grayish color. You know what I'm saying?
You see brown, I see black. And it's just mine.
No, that's because
no. Let me put it in the light. You see it?
Yeah, that's brown.
Pull it up a little bit, but I still see black. That's because
it's not black.
That's
not black. It's not black. I can tell you that, Kareem. I'm right here. It's like a dookie. It's like a real green. It's like diarrhea, but just like when your stomach just hurts.
I don't see that. When you run this video back, you're gonna see that you cannot see what you can see. Even though he see it, you see it, I only see black.
Because you know what? Because that's the way that your retina is grabbing it. And that's what I was saying. Exactly. That's the way your retina is grabbing it.
Now put a dot of black next to that.
Okay, hold on one second.
And if anybody in the audience can see brown, let me know.
Black. So I'm going to show you that the color that you see is not black, because I'm going to put black down so you can see what black looks like. Do you see that?
Yeah.
Those are totally different colors.
Bring it up. I don't see it. Bring it up.
No, you going up, go down. There you go.
Okay, now what I see,
because there's a shadow. Okay, hold on. I gotta put it down. I gotta put it down so you can see.
Hold on. From what you just showed, they both look the same.
They're not.
That's because
they're not.
But I'm just saying though, what I see, it looks black.
Okay, look. Maybe I should show you this like this.
Yeah, you gotta do it. Yeah,
there you go.
There you go. You can see it. Those are two totally different colors.
One just look. They both still look black to me. One just look a little bit darker than the other. They still look black.
Yeah, because the other one is black and the other one is the mixed color. The other mixed color is more of a brown. The black is just black.
But they still look black to me. Everybody to watch this. Darker and the other one. You feel me? I don't see the brown that you can actually see. Okay, maybe it's just my eyes. But
okay, now, sis, I want you to take orange and purple.
Orange or purple? Okay.
It's gonna create brown.
Okay, so now I have an orange.
Orange.
Okay.
Try to do equal amounts.
And then I have we might not have purple. We have shades of purple, but I don't have a purple today, you guys. I'm sorry. Okay. Hold on, let me see it. Let me look at the smaller acrylic.
You can mix blue and red together to make purple.
Well, because I have purples, but they're different kinds. Like, this one right here is light lavender.
It's just gonna come out a beige looking color. That's all.
And this is Velvet Crush.
Yeah, use the
okay, so I'll use a velvet.
All it looked to me is blacker. It didn't look brown. It just looked blacker, and it just looked like two different textures.
Well, I'm sorry that you can. I'm sorry that you need glasses.
Hold on. I'm talking to the audience because I asked them. You feel me? What their opinion is too. It's important. So at the end of the day, I'm not trying to make it seem like my eyes is messed up. I don't see brown, even though you put that there. Only see two dark colors, okay, and they both look black to me. But
Hold
it
on,
just looks
let me go. Let me turn my camera around
looks like
because
different textures.
yeah, I don't know what to say because they're visibly for sure
Yeah,
two
when you
different
go run
colors.
this video back, you're gonna see the same thing.
Okay, let me see.
Yeah,
Camera.
when you mix that purple and that green together.
Okay, hold on. I'm still trying to let her see that these is different colors. And
No,
how
I believe that they different colors. I just can't see that here like
Yeah.
you can see that there. I know he mixed it. I see what you have.
you know
Directly
what
in
I'm gonna
front
do?
of your
I'm gonna go
face.
in the light. Hold on, you guys. I'm gonna go in the light because in my house,
Yeah,
it's kind of
yeah,
the lighting in my house. We don't
yeah.
have all the windows and stuff open up in here. So hold on one second. Now, what colors did you want me to get again? I'm taking them outside.
Purple and green.
Purple and green. Okay.
And the shade of purple that you got when you mix them together is gonna be like a.
I got Velvet Crush.
Yeah. The
This is
velvet
purple?
crush and the green is gonna look like
Okay.
a beigey color.
So let's get some
Like
sunlight.
somewhere in
Okay,
between
let's get some of this vitamin D.
gray. It's gonna be in between brown and gray. Like you know what I'm saying? Brown and gray is like real similar to each other. That's why when you look at some of the old movies and shit, the black and white movies, that's why sometimes they look brown.
And let me get a little station here to do this right quick. My partner chair, he done passed away and I got his chair. Let's do some. Let's see here. Okay, now we got some light. Okay, so I'm gonna put it right here. You guys can see the sky, the beautifulness. Hold on one second. Now we got green.
Yep.
Okay, this is the green.
Try to do equal amounts.
Okay.
Or one
Now I
color.
also want to show this again.
Yeah, show
You
the
see
picture
that?
again.
Oh,
they,
yeah, you can-
they still looking the same.
Go
Put it up.
down.
Put it up.
Go
Put it
down.
up. Put it up. Yeah, put it up.
No. We
No,
mean tilt the
hold it
camera
up.
down.
Hold the picture up.
Oh, hold on.
Yeah, we can't see it when you got it down. Up some more. Or down, whatever.
Yeah.
Okay.
There you go.
It's
There you
still
go.
black to me.
Yeah, that's like a brownish.
No, keep it real. Keep it real.
This right here is brown and that's black.
If you was just,
This one right here
we
is
know
black.
it's brown, but if you was just to look at it, what she just showed, what do you see?
Gray. It's like a dookie brown.
Now what you see, what he see through these camera lens right here.
You can actually see the black mixing into that right now. Look.
No, you are not you. You too close. His eyes. You see two dark color, but one.
You can actually see it dripping into the actual brown.
I know, but
the black.
I know. Now, what do you see? What do you see, Anu Kakaraki?
I see this grayish brown color. It's like it looks like.
What did the audience already said black? Okay.
All right, so mix the purple and the green together. It's gonna make a beige color. Try to use the same amounts, or one color will overpower the other one. Like I think you used more green in that last one. That's why I got.
I did. Remember, I told you that I had. It was a little bit too much, and it wasn't the same. It wasn't the same equality as the blue. That the green was more than the blue. Okay, so now we're gonna go with purple. Okay, purple. Boy, go put my grandson down. You better not drop my grandson. You bring my grandson down them steps. Just like I'm gonna end up beating your ass, okay? Hold on, you guys. Give me my grandson. Go get him a blanket. You don't take my grandson down them steps like that. What if you would have dropped him?
Got that baby. Look at the baby. All right, he could do the science experiment with us.
Okay, so we got purple.
Yeah, and
I have to get my grandson. Hold on, we got the purple. Now let me get the green.
Try to use the same amount.
Give me a blanket. Okay, here go the green.
Yep. Mix them together.
Okay. Yeah, that's pretty much the same. Now, let me show you guys these dots that they pretty much the same. Josiah, bring me that blanket for this baby. Hold on, you guys, hold on one second. Let me get him situated right quick. Hold on one second.
All right.
Josiah, give me that other one. His legs and feet is still out, and I'm doing something. Give me that, go in there and give me that, the paintbrush off the table. Bring me that paintbrush off the table. Thank you. Thank you, Greta. And put some socks on. Okay. Come on, Cash. Now I got you. All right, you bundled up. You ready?
Yep.
Okay, let's see here. All right. He ready now. Okay, so now here's this. It's clean. We're going to go ahead and mix those colors together.
It should be like a light beige looking color.
Nope, it's not.
What color is it?
It's like a green.
Let me see it.
Hold on one second. Let me just make sure that this purple is in there. But yeah, it's like a green for sure. It didn't turn brown like the other one. It's like a green.
Yeah. The green overpowered the that light purple.
Yeah, sure did.
Yeah, just add a little bit more purple in there. That's all.
Yeah, it's two different colors. It turned it like a darker green, but it's still green.
Yeah. Put a little bit more purple. The green is a lot more richer than the light purple.
And remember, this is not regular purple. Remember that.
Right.
I said this is a velvet crushed purple. It's not actually purple. It's a derivative of purple.
Yeah, that's why I was saying if you mix red and blue, you would have got purple, and then you could have just added green to it.
Okay, so now I just added a little bit more. Look, my grandson.
Mix it.
Yeah, look, the kids even want to learn it. Okay, mixing it.
It's turning into a purplish green. Gray.
What is it turning into, grandson?
Gray. Purplish gray.
Turning into what? Gray?
Mm-hmm.
Yeah. Okay, you see it? That's cool, huh?
Yeah, but it's actually brown though. It's not even gray. It's brown.
Okay, so it's
like a dark beige khaki color almost.
Nah, it's not. It's like a here, let me show you. Go rinse that off for me. Thank you. Oh, it turned into like a grayish type of
Yeah,
you see it?
Almost the same type of tint the other one is.
Water.
Yeah, but darker. But lighter. See, this one is like a dookie brown. This one's lit. Okay, look, dang. I got my grandson. Okay, look. Let me just do it like this. This one, you see him? This one is brown. This one is black. Nothing but black. And this one right here is the green, and it's like a grayish, brownish, blue type deal.
Yeah, and it's because purple has red and blue in it. In order to get purple, you have to have red and blue. You see what I'm saying?
I just want to say that all these colors are notably different looking. They do not look the same.
Right.
You can tell black is in the middle. and it's dripping into the other color, and that's how you could tell that there's actually 2 different shades with the other color. Thank you, Josiah. Go ahead and put that in there.
I got a water so you can dip it
The seats in there. Okay, thank you. Put it in the water, grandson. So the pan to come off. Thank you. Close the door so no.
Take your finger, right? In the dark brown color, take your finger and smear it.
The dark brown color, this one right here?
Yeah, take the dark brown color and smear it.
I see a little bit of brownish.
You hear the grandson? He's 7 years old. What color is this?
6. I'm 6.
You 6? Okay. Well, I said almost 7. What color is this right here, Josiah?
It's a little grayish. It with a little bit of brown.
Grayish brown? Yeah. Okay. What color is this, Josiah?
Black.
That's black? Okay. What would you say this color, the top color is?
It's like grayish. It's like grayish mixer. That's what it looks like.
Talk louder so they can hear you, grandson.
It looks like a little grayish mixture, but it looks like it's gray mixed with brown.
Okay. He said it looked like gray, and it's a little bit mixed with brown. The top one, the middle one is black, and the bottom one is brown.
Yeah, that's because when you mix those colors, they're actually making a brown color. You know what I'm saying? And it's the same thing like when we looked at those lights, the red, blue, and green lights together, the shadow when they overlap each other makes that same type of dark gray, dark brownish tone. It makes that same tone. You see what I'm saying? And that right there is just dealing with pigments. You know what I'm saying? So when you're dealing with pigments, you're gonna get those different tones. But when you mix that light together, the photons together, you're gonna eventually get white. You're gonna get white, which is the reason why his screen looked white when all 3 colors were hitting the screen. That's
with a shadow.
You know what I'm saying? But the minute that he put an object in front of it, then you was able to see the shadows. And once you seen the shadows, it allowed the shadow colors to blend together. And when they overlap,
it did.
You know what I'm saying? Just like the overlapping is the equivalence of you mixing those paints together. You see what I'm saying? So you know what I'm saying? Like that's what you did was an experiment. That was a science experiment that you just did.
We just did an experiment, Josiah.
That was a science experiment that y'all just did. You know what I'm saying? Just dealing with colors and pigments. You know what I'm saying? Now all y'all got to do is make a bunch of odd shapes on that canvas and sell it for $300. I'm dead serious.
For real, grab the colors, grab the stuff so I can put the baby down.
It could be his
grab
first
the colors.
You know
my daughter is an artist, so that's where we got all of her stuff. My daughter does a lot of abstract paintings and stuff like that. That's
I envy her because as much as I love art, the hardest thing for me to do is abstract. So I envy her.
Yeah, let me show you a couple of her things. Get in here, Josiah. Thank you. Come on, baby.
I love art.
Okay, she's done this one.
Oh wow. Oh yeah. See that's some masterpiece shit right there. Like I would never be able to do that right there, man. Like my brain is so symmetrical.
She just puts it. My daughter's very talented when it comes to art.
See the emotion. You can see the emotion in the painting, the color, the vibrancy of the colors. You can see emotion in that. You know what I'm saying? Like it's a lot going on in there, man. And then like her choice in colors, complementary colors and stuff, and contrasting colors. It's popping. Like yeah, that's a masterpiece. If I was you, I would be trying to get that painting sold.
Yeah, my baby, she do a lot. She got a lot of gifts to go over there with your brother and check him out while I'm going upstairs right quick. Go sit with your brother right fast.
Somewhere, man. You know what I'm saying? That's the type of art that you see in doctor's offices.
And look.
She did that too?
Yes.
Oh, wow. That's
it's
crazy.
on the wall. It's on the wall in my home.
It's two people kissing.
Yeah.
My eyes want to tell me that it's two people kissing, but
yes.
My left brain is saying, nah, nigga, them are random squiggly lines.
Right. This is it's love.
Yeah, I see it. I see it.
Yeah, she put it's love. Just with a couple.
Oh, and
yeah.
Have you bought her an airbrush gun yet?
No. I have. See, she does.
Buy her an airbrush gun and watch the magic happen.
See, this is her with her paintbrush.
See, I could never do that shit, especially with that color combination right there with the greens and the orange. And okay, zoom in on the one with the white background, and if you can look and see where the green and the orange is colliding at, look what color is creating. It's like this brown, that same brownish grayish.
Yeah,
color.
I see that.
You see that? You see what I'm saying? And it's the same thing.
You can see it good right here too.
Yeah, you can see it. You know what I'm saying? Now we dealing with straight up colors. You know what I'm saying? The black itself don't have colors.
Yeah, the black is separate.
You know what I mean? So like even man, like that should even look like it's textured. Is that textured?
No, she just did this with a brush. My daughter's very talented. She gets that brush, or she does with her fingers, or she does splash art. She does all that. My daughter, that's her thing.
I do art, and I cannot do abstracts. Like I can do them, but I have to superimpose something symmetrical on top of it to make sense of it for me. Like my brain will not allow me to make chaotic art. And like I envy artists that can go into that chaos mode like that and just do that, because I don't see life like that. You know what I'm saying? Them artists that see life like that are a gift to humanity, because I don't see it like that. You know what I'm saying? You should buy her an airbrush gun and watch the magic happens, because she's just using a paintbrush, but that airbrush gun is gonna allow her to manipulate her pressure, the pressure of the paint and the intensity of the paint. She's gonna fucking love it. I swear to God. It costs about you can about $100 to get you the entire kit. It'll get you the entire kit with paint. You know what I'm saying? She
has a lot. I spend a lot of money on art stuff. She does this stuff. She just thinks.
Don't ever stop doing that. Like promote that shit.
Yeah, she just thinks.
However much money it take, just pump it into her, because as an artist, I'm telling you, the one thing that artists.
You know what I did with her? What she does as well, because art and music go together. So this is her too.
Oh, that's tight. That's tight. I was never a musician, like playing instruments.
So she just loves arts. Yeah, she loves music. She loves the sound. She loves that's how my baby get down.
Don't ever trip off how much money that it costs to bring her gift to fruition, because the one thing that most artists, this is how most artists fail, is because they don't have somebody sponsoring them. Artists need sponsors, meaning they need somebody to take care of them while they create. An artist needs to be put in a room, locked in a room with paint and all types of different.
She does that when she calls that her zone.
Yes. Like artists need.
Yeah, that's what she calls it. She calls it her zone.
Very confined and allowed to just create. And the more she's allowed to do that, she's gonna create masterpieces that'll feed y'all family for generations. I swear to God. But she needs somebody that's gonna sponsor her.
I know.
You know what I'm saying? She needs somebody that's gonna sponsor her. I created a business, and our whole purpose in our business is to bring back the assessment value of art back into our community. You know what I'm saying? Because
she's very artistic. Her imagination is sometimes scary. Sometimes the creatures that she brings forth
Yeah.
She does really good with anime, things of that nature, showing like I need to go get her scrapbook. Her scrapbook is like her diary.
Like
Sometimes she gives it up and sometimes she doesn't.
they say that artists are akin to God, next to God. You know what I'm saying? Because she can create things out of nothing. In her
Yes,
head,
what she sees in her head. Sometimes I say, "Oh, it's beautiful," but sometimes I say, "Oh, wait a minute, where'd you? This dragon has
yeah,
stuff going on, and
yeah,
this
yeah,
woman, she has 3 eyeballs, and this eyeball is doing
yeah.
this, going to the left, and she
Now here's
sees these
the
things."
crazy. Now here go where my eccentric pseudo shit comes. Because she created that, somewhere in the fucking universe is gonna create that shit. It's gonna
Yeah.
create that shit. It might not be on Earth, but that somewhere in the universe, she just created another being. She just created a spiritual body for that being to come into
She
existence.
sees it in her brain. I always ask her where she gets she says that they're in her dreams,
Yeah,
and
yes.
she puts her dreams on paper.
The brain is where the spiritual body came from. She created a spiritual body in her head, and then she painted it and brought it into the physical realm.
Yeah, that's what she does.
She bought what was in her mind into the physical realm. It crossed dimensions. It went from a thought into actually being in the physical world. Now,
Yeah, she does that all the time.
Somewhere down the line, the universe is going to create that thing because she created a spiritual body for it, and then she brought it into fruition onto the canvas. And the universe ain't going to do nothing but answer that. That's how art works. That's the reason why they say artists are akin to God. You see what I'm saying? Because of their ability to create. You need to foster that gift in her, and as much money as it takes, keep pumping it behind her, because that shit's going, when she make her first dollar off of her artwork, it's gonna change her life. The minute that you need to get her artwork sold, and the minute that she sees that she can make money off of her art, is gonna change her entire life. She will never seek to be somebody's employee. She'll never seek to be somebody's.
Oh well, she gonna have that entrepreneuric influence anyway, because both me and her father own businesses and we are entrepreneurs. She loves music. She loves just art forms. She loves this, like, she's different. Like when most of the girls, they wear like skimpy stuff, little stuff with their booty hanging out. She's not like that.
Nah, most artists not. Most artists.
Okay, so let me. I just wanted to pull some of the stuff out just from a little bit of her scrap, because these kids are what we need to be focused on, And then she has. So this is like this abstract with colors, right? Learning the wheel.
Face it away from the light. Turn around. There you go. Yeah.
Just her messing with colors and how.
It's like, what is that? Like a collage of shit?
Yes, it's a collage color wheel.
Oh wow! What is that? A Volkswagen? That's a Volkswagen.
And each one of them have symbolism in them.
That's tight. I can never do that shit, but that's tight.
And then in regards to colors and what she sees in her brain, and this is what I was saying, like she just sees things in her brain.
Yeah, see, yeah, I'm not that type of artist. Like she on a different level, man. Like that.
She just sees things, and things come together. They just come together.
Like she's on that Al Salvador Dali shit, man. Pull up some Al Salvador Dali for her so she can see that.
And this is one that she did that's something like that, but this with circles.
Yeah, that's like Rembrandt and Al Salvador Dali. You should introduce her to Al Salvador Dali and Rembrandt.
Yeah, she does a lot. This is pencil work. Just a little bit of pencil work. Just a little bit.
Oh wow, that's her pencil work. How old is she?
Just a little bit. She's 16. Just turned 16. Just a little bit of shading, but she has some awesome. This is this baby shade. Let me show you a real shade.
when she learn perspective, she gonna be fucking dangerous.
His birthmark.
Oh, that's nice too. When she learn perspective, she gonna become dangerous. Her art gonna become next level. Like seriously, like sit her down.
There's something that we were talking about. Look at this one.
She did that?
Yes, sir.
Damn.
She sees things in her head.
Now when I look at that shit, you know what it looked like to me? A butterfly. It looked like some type of weird butterfly.
It's two people looking at each other.
Yeah, I see that, but it looked like butterfly wings to me, like a
Yeah.
Yeah, it looked like a butterfly. You know what I'm saying? Like that. Yeah, man. Like
it's like spirit, right?
Gift that needs to be promoted and fostered. Like you got to put some money behind her and actually push her towards that goal, because artists become distracted. They become discouraged when they don't sell work. When that shit don't sell, she gets discouraged. Even if you
look at this person that's sitting on the edge with that cross.
Right.
Everyone's sitting on the edge. You see it?
Like, understand this. Even if you have to buy her art yourself and give it away to somebody, don't let her know that that's what you did. You know what I'm saying? But the minute that she start making money off of her artwork, it's gonna change her life, because it's gonna go from something that she just do for fun to like, wow, this is a marketable skill.
This right here is what I'll be seeing. Look at, okay, so on this one, you see that person hanging?
Mm-hmm.
You see it's back in the back, but you see that snake, he's in a box. You can't really see it, but the snake is in the box, and he just now let everything out, all the garbage out, and there's the garbage.
Damn. Yeah.
And then he has other people, and this life has people sitting on edge. You see the edge, they're all sitting on the edge.
Wow.
That person has a cross. He's looking at the cross, but he's also on the edge.
Wow. Right, because we don't know if that's open in the background.
Yeah, you see, it's open in the background. You have the sun, but then you have somebody watching over everything. It's a woman. You see her?
Yeah.
She's in the sky.
So she's already learning perspective.
Yeah.
Yeah, I see it. She's already learning perspective.
This is this from the world. So this is this different color she got from the world. This is all material, like water paper.
Really?
Yeah, this is all material.
That's not paint?
No, this is material.
Huh. That's nice too. Like my suggestion to her on stuff like that, when she making those mountains, she ought to wrinkle that shit up and then glue it down and get that texture look to it, like the mountain got actual ridges and stuff like that in it.
Yeah, like this is stuff too. I don't know what this is.
What the fuck?
But it's the pages of it, and it's like frequency.
Yeah, man.
It's moving through stuff.
Artistic genius on your hand, man. You need to most definitely cultivate that, just like you cultivate.
So she has frequencies going through a fish, frequencies going through a bird. It's actual energy, and she's colored that energy going through those things. Look, check it out.
Well, she ever get her hands on some acid, it's gonna be.
You see that fish? And that energy is going through that fish.
And she just come up with that shit.
So I don't really know about colors, but my daughter is in. That's why I got her little art stuff to get the colors and stuff like that, because she knows colors. She sees colors in her sleep. When I asked her, like, where do you get these ideals? She told me she sees them in her sleep.
Yeah, and that's crazy, because most people that I talk to, when I talk to about their dreams, they say their dreams aren't in color, but my dreams are always in color. I've never had a dream that ain't in color. All my dreams.
Yeah, her dreams are very vivid as well.
Yeah,
she won't let me have that actual book. She just said, here, you can show them this. That actual book will have you like, whoa, shit, okay. Yeah, that book will have you like, okay.
Perspective, I'm almost sure she's heard of Al Salvador Dali, but she needs to study Al Salvador Dali's work because what she does is real
Put the
similar.
name of that in the chat, and I'll pull it up and get it for her.
Let me see if I can find it. Al Salvador Dali. Matter of fact, I will do a screen share so we can see. So you can see like she's on the same page with him. Look at this. This is Al Salvador Dali. It's real similar. That's Al Salvador Dali. When he makes paintings and stuff, they're all like melting and like these different colors, and you know what I'm saying? It's people inside.
Ooh, look at that. That's beautiful.
You know what I'm saying? This is Al Salvador Dali work. This is where she's headed. She's on a whole nother level. Like this is like the emotion in these paintings.
She has something that you see where you going up the second column and the second picture over, she has something like that. With this person, it's a person. Go down. Right there, that. She has something like that. But it's different.
I'm saying like
it's a spirit. She says the spirit.
What is that saying? Like, what is that? Like I could never do art like this. That's way too this is way too abstract for me.
Look at this one. This one right here is with material as well. It's a kitty cat.
Oh, let me take a look. Yeah, I've never did the art with the material thing.
Yeah, so they just cut out materials or whatever to make the art.
Do you let her play with Play-Doh?
Yeah, she has Play-Doh. She has whatever she needs. The only thing she don't have is that airbrush gun.
Yeah,
okay, so here goes a little bit of her playing. Now this is called homosexuality.
She did that?
Yes.
She called it homosexuality.
And you see that the girl is not crying, but when she turned into the boy is torn. He has a tear.
That's not what it is.
This right here.
Damn.
That's what these kids going through, right? That's what they got to face at school. That's what they got to face in the world. That's what they got to face coming at them at all times.
Yep.
This.
Yep. And that's sad. Because I wasn't thinking about none of that shit growing up.
But they have to.
Oh,
this right here is identity.
Yeah, man. They've been pushing that identity politics stuff on our people, man. And they've been doing it for a while, actually. We just now started to become woke to it, but they've been doing it for a while. I mean, even way back to like In Living Color days. We didn't know they was pushing that shit on us, but they was. And we just thought it was funny. That's nice.
So she got a little bit of art. She does a lot of stuff. This is the eyes.
The eyes, I thought them was eggs or solar systems. Them look like solar formations and shit.
Yes.
That one looked like a binary star. Yeah, man. I can't do that abstract shit. That symmetry shit be making me
There go that pencil.
Yeah, man, she good. Wait till
she gonna get better as it goes, and here goes this color. artistic Africanism.
Right. That's what I'm saying, man. That shit look like El Salvador Dali shit, man. She got a speaker on her head.
We turn. Oh, look, and this is what she love, honey.
Yeah, she know perspective a little bit. I see that.
We gonna get. We have to really get our kids to know who they are.
Yeah, she put some time in on that. Yeah, she put some time.
Yeah, that's my baby. My baby love. I'm trying to see if cause she can sing. She does art. I think this one is gonna be. I got my other kids, but she the baby. The baby is real artistic. The baby know how to sing, play the guitar, do art. The baby is different than the rest of them.
That baby.
The baby, yeah. I wish I knew that when I had my older ones, what I knew. You know what I'm saying? Because the older ones, they do good too. They doing all right too. But I think this one right here is gonna be something different. Her goals and things that she's interested in is way different. And she sees things that we don't see. Literally, and she puts it on paper. So what do you feel about what we've seen so far in regards to the experiment that we've done here? Does it prove or debunk the fact that black has the same electromagnetic wavelength as an X-ray?
I'm with you. The debate done. That shit was a negative. You know what I'm saying?
Yeah.
It was a big no. Now at this point, it's about proving if black is alike. I agree.
Yes, I think that should have been the topic.
No.
Well, I think that would have been even more harder for him to demonstrate than the X-ray thing. Like you know what I'm saying? Because it absorbs all electromagnetic radiation. So he would have to show black being projected like light does. You know what I'm saying? Which it doesn't unless you're talking about a shadow.
What you doing here? I feel like don't color on them. Them as your aunties. Get you a coloring book, grandson. Yeah, I know. Here, go up in here and get you some coloring books and ask her for some color crayons or some markers. You want to do some painting?
Got the whole house doing artwork.
I know the kid, because the kids love the little kids. They want to hurry up and put the little special hat on and the little smucks and think that they Picasso. They love doing that. Put the little painting little thing up, the little wood thing that they put the little canvas on. We have parties like that. These kids love it.
Hey, look, tell her she can create her own paints and dyes by going to the store and buying flowers.
Oh, she does that. You know those? Let me show you. Let me see if she got one. I think she sold them all, honey. She had doll heads. What she did was, those wigs, those wig heads. She go into the nicest and stuffed a whole bunch of flowers in their heads, and then put makeup on them and colored them. They black, but their hair was like an afro, but it was all flowers. It was beautiful. And she was selling them.
Yeah, man. Like that. Like I said, man, you got one, cuz, and you just got to put the right amount of energy, time, put her in the right places around the right people, man. And that shit gonna blow up.
Well, she going to college. We already got that determined. We trying to make sure. We trying to see if she gonna get a full ride or a half ride, but she going. That's what we just. Well, I wanted to go to an art school of technology. Yeah, the School of Technology is here in North Sacramento. It's called the Art School Institute of Technology.
Yeah, that's why I had wanted to go once I had got out of high school.
Yeah, so her last year she'll be going there. We have to pay. It's not
that's not cheap.
It's not a free public school.
No, it's not cheap at all.
Yeah,
like I said, when I was young, that's the school the Art Institute is where I wanted to go. But shit, we didn't have the money. That shit wasn't in the budget, man. Like, so.
Yeah, see, me, that's why we're getting that together now. So her senior year, that's what she will be.
Yeah, and she's 16. Shit, she can get a job now, nigga, and be stacking.
She got a job.
Well, tell her to stack her money up because
she worked for our community association and the youth program, and they do all kind of stuff. Art, of course, right? Yeah. We real connected with our community. I'm the ambassador of our community association. My brother is the ambassador for the city of Sacramento. So there's programs that she's always involved in. What they do is they give the kids what they call that payment that y'all get, Cherish? It's like a little stimulus, but it's not a stimulus. It's for going to the program. They give the kids like $1,500 if they complete the program. And the program is like financial literacy, art, job readiness.
I wish we had that when I was growing up. Shit.
Yeah, they give them like $1,500 too. They you know what I'm saying? They give them $1,500. So just imagine a kid, either you can stand on the corner and end up going to jail or getting killed, or I can go to this program and I'm gonna have $1,500 and I ain't nothing but 15, 16 years old.
Yeah, I ain't gonna lie, sis. Like before I started doing artwork, I used to sell drugs.
Right.
And I used to sell on the corner and sell drugs, sun up to sundown, just to make re-up money to buy the same kind of drugs that I had just bought. You know what I'm saying? And one day I was sitting on the block and I had my portfolio right there drawing. Somebody walked up, seen it, and bought one of those fucking paintings for me for $25. And it was there. It was.
You was like, what?
At that point, I knew that I didn't have to sell drugs no more. All I had to do was concentrate on my art. So I started doing art. Then I started doing tattoos. I ended up doing
tattoos are hard. That's art. Then hey, tattoo artists are important. Let me say, hey, shout out to our tattoo artists, because they'll fuck you up for life if they don't know what they're doing. Yeah. You get cracklets in your skin. You know what I'm saying? All type of stuff. So shout out to any good tattoo artist, for real, because I've had some garbage put on me and it had to stay there for years until I had to get, cover-ups and stuff like that. So shout out to the artist that makes you not have to come back and go to somebody else.
So I did tattoos for a minute, and then I had stopped doing them and stuff because I was really just basically winging it, teaching myself. Before I had one that got an apprenticeship through Black Pearl, right?
Okay, so what is that? What is Black Pearl? What type of organization is that?
It's a tattoo studio.
Okay.
Now, what happened was once I basically ran out of ink, ran out of needles, and all of that type of stuff, I didn't have none of that shit no more, so I stopped doing it. But I ran into one of my mentors named Pharaoh Jarumba and Michael Howes. Both of them are renowned artists here in St. Louis. And what I did was I studied up under them while they was doing the airbrush. And then they allowed me to play with their equipment while they wasn't there. So then I learned how to use the airbrush gun and then surpass them, because my artistic skills were already on par with them, but they had more experience dealing with different techniques. So I learned the airbrush gun up under them. Then I started airbrushing t-shirts. Then I started making money off the airbrush t-shirts. Made enough money to buy more tattoo equipment. You know what I'm saying? And so like the two kept funding each other. So after I made money off the t-shirts, I would turn around and buy tattoo supplies. The tattoo supplies made more money than the airbrush shirts. You see what I'm saying? So I was and I've been doing tattoos ever since, on and off. I've been doing them ever since. You know what I mean? And now I'm like, damn near 17, 20 years into doing tattoos. You know what I'm saying? But I'm over 30 years doing art altogether. I could sculpt wood, stone, glass. You know what I'm saying? I could make my own paints. I do graphic arts, graphic designs, layouts,
Okay.
menus, backdrops, business cards, anything that deals with art. I can either learn within a week and master within a year. You know what I'm saying? That's what your daughter, that's what you got. That's what you got with your daughter. You got somebody who has the ability to learn these techniques and master them in a fucking year.
Yeah, she's very intrigued.
Within
Very intrigued. That girl will sit up in there with that guitar.
her shading techniques, with her shading techniques, and I'm looking at her. With her shading techniques, that airbrush gun is gonna take her to a whole nother level. And
I'm gonna order her one off Temu today.
On God.
I want to go to Temu to give her one. Everybody be talking about Temu. Temu work. We Temu regulars over here.
It's Team Temu.
Yeah, Temu. We Temu regulars over here because it works. Everybody, we don't know. No, Temu works, honey. We regulars over here. And I'm gonna go on up there and get her an airbrush today. Cherish. Order yourself a airbrush and put it in the cart on Temu.
Do the kit.
The kit. Just do the whole kit.
Yeah.
Look, she's cheesing now. She happy now. All her braces showing.
Look, listen, this is what I'm trying to tell you. Like, I love using paintbrushes. I love them. Like, that is my heart. I love using paintbrushes. But that airbrush gun, oh my God. Like the amount of control that it gives you with the paint. And
I think she gonna love it. Once she get it,
oh my God.
We'll be back to show you what she do. Because once she get it, I know my baby, once she get it and she see what it do,
oh my God,
we gonna have all kind of stuff. But watch us have our nails done. We gonna have colored on everything. That's what she
no idea. You have no idea. All her shoes gonna be airbrushed.
Right.
She gonna have a line of people calling your house and lining up. Like, can she do this for me? Can she do that?
And look, and you know what's crazy? You said that, hey cousin, what's up with you? Hey, good morning. Good morning. What's up, family? Shit. This is what I wanted to show you right quick. Where you gonna be like, oh nah. Because what she gonna do is this is what I wanted to show you. My guest room here. This. She already got this. She don't even use it.
Oh, she got a press.
She don't even use it. She don't use it.
She got a press.
That girl don't use it.
Yeah, man. Yeah, man.
Don't even use it.
I'm trying to tell you, when she gets the airbrush gun, she will
use an airbrush gun.
Yeah, because what she gonna do is, once you airbrush that shit on the shirt or some pants, you want to put that on that press and cure it.
She don't use it.
She gonna use it when she get the airbrush gun.
Right, the girl, she like a kid. You know them kids, they want everything, and as soon as they get it,
look,
they play with it for a minute, and they don't want no more.
I guarantee you, once she put that shit on,
you know how much that thing costs?
Yeah, I do.
That thing ain't cheap.
No, it's not. I guarantee you, when she start airbrushing t-shirts and stuff, she's gonna be using that press to heat treat the paints on their shirts so that they cure in the shirt. So when you wash them, they don't fade. She'll be using it. It ain't gonna go. It ain't gonna go dormant. Like, that shit, that's crazy, man.
Well, I'm gonna have to get off.
All right, sis.
Peace, sis. Peace.
Peace.